Hi, can you hear me? Hello. Hello. Hello.
Hello, we can hear you.
Okay. I need to adjust some audio here. Apparently, it is echoing very heavy on my side. Can you speak something? Just a bit? Just say something. Hello.
Hello.
Okay. Just testing audio, and we should be good. We should be good now. Do you see me?
Yes, we see you.
Good. So I think we are good. We are getting ready to start. Okay. We should start. So we did not have a session yesterday, so this is a replacement session for the one that we did not have yesterday, which is what we discussed, and I think you know that. So nobody actually showed up. Nobody showed up on Zoom yesterday. That is nice. So at least I did not cause any confusion. And with that understanding, the topic that I want to discuss and share with you is about understanding how do we take a approach to a given cloud architecture, and how do we play that out in the context of a given cloud. So we will begin with this Amazon cloud and our goal, that the idea that we have. Let me just illustrate the core idea here. Just a minute. I'll draw it out to explain the points, and then we'll begin in terms of understanding how do we essentially automate creation of a elaborate cloud scenario that we did. I think you remember we did this and not logged in. Interesting. So let me log in quickly. And once I log in, I should be able to take you to the same point, which is where you have done this exercise, by the way. You did it manually. You did it like by a point of your mouse and mouse clicks and things of that nature. You did that whole exercise pretty much, but you did it manually. And so that manual process that we follow anytime, it has this likelihood of getting broken because people are involved, right? When people are involved, it is difficult to accomplish something in a repeated, predictable fashion. And so we did this complex exercise where we created, a VPC, multiple subnets, put a NAT device, created route tables, security groups, all the things that are needed to make sure that a particular virtual private cloud, according to what we would like to see, is ready for us in the context of Amazon Web Services. So you recall this, we create a subnet for public area, subnet for private, then we put a NAT device here, put a jump box here, and have a gateway defined. That gateway connects directly to these NAT devices, to jump boxes, and we have our application server behind the scene in a private subnet. This is our application server. In another subnet, we can have a database subnet, and we have database boxes here, DB boxes here. On the NAT device, we might have some kind of a VPN setup already inside. This part I don't think we did, but we did set up a method to connect from here, from outside, from our office locations, to be able to go in through and through the jump box and just connect to any machine that we feel like on any subnet, whether it is a private subnet like these guys or a public subnet like this. We were able to traverse through, connect to any machine, and have our application deployed. So we will do this exercise, which took us a fair amount of time to build the whole thing, because first of all, we were new to this. We were trying to understand what does it take to create a given blueprint for a given architecture. And then how do we understand the details behind a NAT device, jump boxes, SSH tunneling, understanding subnets, understanding the difference between private and public subnets, understanding that, the traffic that needs to go from a machine that sits here, maybe on a private area, should not go directly through a public gateway, but should traverse through the NAT device. Those security aspects we understood. And, repeatedly doing this whole exercise again and again and again, asking you to delete your VPC and just start afresh, can be cumbersome and really difficult. And you can get very quickly bored by doing that. If you're doing it by hand, you also have this chance of making a mistake, right? Just accidentally forget to do something like the time I did with you. I remember I forgot to put the NAT device in a source destination check. Source destination disable. This check has to be disabled. And this is the thing that I forgot completely. And then some things did not work out the way I wanted them to work. Do you still see my video, or was it lost?
Yes, Nilesh, I saw you.
Do you still see me?
Yes.
Okay, good. I was afraid it was like getting lost a little bit, but the thing is that this connection somehow broke for me. So it may have been broken for you. That's nice. So we make mistakes. We are people, and so I forgot disabling this source destination check in my first attempt with you guys when I was doing that exercise, and that is something that you want to actually avoid. You want to avoid mistakes in production, especially when you're dealing with large-scale deployments or production deployments or dealing with customer situations. You do not want mistakes, and that is why we want to do this whole exercise in a matter of few minutes, but using automation. And you will see it. And I will be using a tool that is called Terraform, which is an open source tool, as you know already. This one, which is opening up, the website is opening up, it is available on GitHub. And we will be using this tool in our virtual machine, which is this machine here. And what we will do is just play the exercise, and you will see that a complete
the same thing.
Sorry, missed that. I missed that. So if you're saying something, I missed it. So I'll keep going. I'm assuming that you did not have anything for me. If you do, please stop me. And so what I am doing is going to this exercise, which I have called out somewhere along our architecture section, where I describe module number 10. And so where is that? Yeah. So the source code that we will be using is this particular location on GitHub. I'll be pasting a link for you, and you can actually follow along. Give me a second. Thank you. And so what I will do is follow along in our link on Slack. You can actually do this with me. So I will be going to this machine here and cloning that repository as shown on GitHub. So I'll open it up in Firefox in the web browser, and here that same repository opens up like this. I'll grab the SSH HTTP link from there for cloning or downloading HTTPS link. Grab that and bring it down. So that's the first thing I will do is basically in my terminal, make it a little big, and then git clone and clone that link. It is a very, very easy to do exercise because the whole thing is done for you, automated. So we have this cloned out, locally. This is available to us in this folder, ANTR architecture. And that folder is what we want to go inside. Since that name is kind of very long, I would like to rename it, something like a very short name, like something this short name, so that the command prompt doesn't get occupied. Otherwise, my command prompt will be full of that detailed long name. So I just renamed it just to simplify the command prompt here. This portion, I just shortened its name by renaming that so that it doesn't cause any visual display issues as I'm talking to you and illustrating the points that I'm doing. So in this folder, I have basically one subfolder, and that folder is called Terraform. That shows up here, and it has a bunch of things in there. So I think it is easier to see it in this fashion. When I expand the tree in when I expand the tree, you should be able to see it. And so this tree application is getting installed. And then I will expand the tree to show you that it has most of these things in the Terraform folder. And these are the files that are already in place. And we will understand what these things did, but not in the first time. With first time, just blindly run it to understand what's going to happen. That's what my plan to begin with right now is. And I will make sure that I clarify that this is the folder. And here are the bunch of files that we need that are already made available to us. And this collection of files is using Terraform tool already does what is expected is to construct a virtual private cloud, pretty much like what you saw in this other exercise that you have done already in a cloud technologies program early on. So you know that already. And that is this lesson that we did, long sequence. That one that I mentioned, the same exact thing, except it is completely built through automation. And the automation tool we are going to use is Terraform. And so Terraform is available on this location, as you know already, Terraform. And if you visit that site, that is where you can actually grab the tool itself. And so we will download that tool and download it for our operating system, which happens to be Linux 64-bit. So we'll download it for Linux 64-bit and let it come down. It's a heavy package, by the way. And so it will go and sit in our download folder. We'll let it go and sit there. In the meanwhile, we will understand that what we need to really do in this particular exercise at the very first run is to, let me go there, is to, let me go to the exact location where I'm reading it through from, so that I will also be able to give you a link so you can actually play along. And it is very easy to actually do it together. There's nothing cryptic, or you're not going to run into issues, I hope. And so we are going to the architecture segment. I'm grabbing a link for you where I have this written down so you can follow along. And you will need an AWS access key and secret, by the way. And so that link is module number 10. And that is what I'm grabbing from here. And we will follow along as it shows in that write-up. That's the link I will follow. And I have it open here already. And the first step needed is to make sure that we get the Git repository going, which we have. And then we will just make sure that we have this Terraform tool installed. And if Terraform tool is not installed, here are instructions on how to install it. And so those instructions are made available in this section that we will follow. It is actually very easy to install. We will go here and look at the download section, which is where we have our things downloaded. The Terraform tool has been downloaded already. This big package, this Terraform whatever.zip is available to us. So what we will do is unzip it, unzip Terraform, and then it unzips. It is a large package, I think about 200 MB files. And so it is provider for every cloud provider. As you can see, all these providers that Terraform interacts with, you can see that we have expanded it. We have all these files available in our download folder. There is also a file, which is the Terraform zip file, which we do not need this zip file anymore. So we can just get rid of the zip file itself. And I have cleaned it up. What I also noticed is that in our folder, we have most of these files with the name Terraform. And so you will see that all these files need to be moved to a particular location. And that is exactly what I will be doing. So I'm going to make sure that I'm not missing out anything. So all these are executable binaries, as you can see, executable for a variety of cloud providers. And so that's the entire collection of all the Terraform expanded zip files. The zip got expanded, we have these files, so we want to move them to a location where we can execute them. And that location happens to be this user local bin. Is a good location to move them to. And if you want to move something to this location, user local bin, you require super user privileges, and otherwise this location is protected. You cannot go there. And so you have to use sudo. And so that is what I will be doing, is I'm basically taking this command, basically moving all the Terraform binaries, these files, all of these, from that current location, which is in the download folder, and move them to user local bin, just to put them in the path, in our path. In our path, by path I mean a place where I can execute them. So I'm just moving them all, and I did. So we have nothing in the downloads folder, and we have everything moved out to user local bin. And so that is where you will find all these Terraform binaries available to us. And by the fact that they are now in user local bin, the binary location is in our path, so which means we can execute the Terraform binary right like this. And so we can see that it is available in our path and actually is executable, which is great, because now I want to actually go inside the tree, as you see here, and go in that subfolder called Terraform under our TF folder, which is the one that we downloaded from GitHub. We have to go inside this folder and access a specific file, this one. This file is where we will place our AWS access and secret key pair. So this terraform.tfvar file, we have these two lines, change this and change this. And this is basically a ready-made file for us, given that we can modify it and put our secret access keys in there, and then Terraform becomes usable to us. Without these keys in place, Terraform is useless. It will not work on our cloud, in our case of Amazon Cloud, to be specific. And so we want to actually be working in that subfolder. So I'm going to go inside in that Terraform folder like that. And now my current location is whatever that download location was, and then I went one step below to Terraform. And here I see these files that I want to actually use. In here, I also have this file that I want to edit. And remember, that file is currently in a fashion which is generic. Generic as in it just says, change me, I'll change this. And that is what I want to change. I want to change and put my access keys and secret right in there. And you have to keep these secrets really, really secret, so don't share it with anybody. But I need to share it with you, and I'm okay with that. I need to share it with you because I need to show it to you. So otherwise, how will you understand what's going on? So here, I'm going to create a key pair. And just the fact that I create a key pair every time, and because every time after the end of the class, I delete the key pair. Then that key pair is gone. Otherwise, my videos go on YouTube, and I don't want people at large to access my account, honestly. So that's why I delete them. You make sure you also delete if you accidentally expose your key out to somebody. You should make sure to delete your key pair. Now, I'm going to basically here create a new user. And I'm going to call this user Terraform. And generate a key for this user, the Terraform user. And I will create a key pair. And the key pairs are available here. So I'll just grab that key. This key goes in my access location, meaning this location. And then the other key will go in the other location. That's what I want to do. So I will edit this particular file called terraform.tfvars. And that file I will edit like this and modify change this and insert my value. And then I will also change the other key, which is I want to grab and paste it in this location. It's very, very simple to do. You just need to be aware that I'm using some editor that you may not like. So just use Atom. I'm using this editor to make sure that you can see properly. Atom is somehow showing you very small fonts. That's why I'm not using it right now. And I just included my secret as well as access key in that same file in this particular fashion. I'm going to exit the editor. And now you can see that catting out that content will show me the correct value of my change. This has been replaced by this number, and the secret has been replaced by the secret. That's great. Now, we are ready. We are practically ready to run Terraform, except this user does not have any permissions. So I will have to provide permissions to this user by making sure that this Terraform user is added to the super duper admin group. And now that particular key activates and gets powers to operate on my cloud. So I'll go to my Amazon location and I'll stick to Northern California. By the way, the purpose of this first time you run it, please stick to Northern California. And you can later on change it, but at least for now, stick here, Northern California. And let us then go to our VPC section. You will find that I have only one VPC, which is the default VPC. And that VPC, as you see here, is the only one I have, and I will leave it alone, not using it. So we'll create a completely new VPC, but through automation. That's what you will see now. And in addition to that, we'll also start some machines inside our infrastructure, our architectural layout. You will see that happening as we begin. So let us see where we were. We are here. And we have expanded the Terraform zip file. And we are going to be inside the Terraform folder. We are going to edit the working folder and get our credentials. And then in that, we will put the credentials like this, change this, we'll change them. And then we are to inspect this variables.tf file just to make sure that it contains a critical ingredient. And so that file that we are looking at is this variables.tf file. That's what I would like you to see. And so here, I'm going to open it up in Atom Editor. And just make sure that you see it. And it contains a couple of details, as you see here. One of them is that you need to make sure that you are defining your access key through the other file that we did. We are defining a US West 1 region, which is the Northern California. That's the default choice I have made for you. You can change it later, but don't change it in the first time you run it. You have to select Amazon AMI for Ubuntu operating system, which is the machine that we will create. The AMIs are already included. You don't need to change them. And with that inspection, we will close that file out completely and quit Atom and be ready for us to run. And running is very simple. All it needs to do is Terraform apply, and it will prepare the whole stack, prepare the whole architectural layout, all the things. You will see it happening, and then I'll walk you through step by step. We'll create the whole thing, and then I will destroy the whole thing, and then do it step by step, item by item. So you will understand what's going on. How do you automate? How do you make it even more elaborate and customize it to your needs? But this is basically a representation of what we have already done through manual steps. So that is why I do not want to go slow, but actually run the whole thing in one shot to get you a quick feel of what it contains. And then we'll destroy the whole thing. And then we'll create it the next time, but one line of code at a time. So you will really understand what these files actually do. But at the entirety, all these files together will constitute what we would like it to become is a cloud, a virtual private cloud with public subnets, private subnets, machines, NAT devices, security groups, VPC, and your VPN server, all of these things included in here. There is one more critical thing that is needed on your machine, and that is to make sure that you have an ID RSA file. That is that is expected. So you need to have that file already, which should be showing up in this folder. You should probably already have it, and I probably do not have it, by the way. So in that folder, you should see. Okay, let me go there. If don't even have the folder apparently. Okay, in my machine, I don't even have that folder, which basically means it's a new machine, which means I need to create an IDRSA key pair. How do you do that? SSH keygen. Enter, 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 enter. Now we have it. So now we can see that I have this SSH key pair called IDRSA. This is a requirement. You have to have this key in your .ssh folder. And now we are actually ready to execute Terraform. And we will do that right here in this location. We'll say Terraform and apply. That's all it takes to completely construct an entire VPC, put your subnets, configure NAT devices and all that. But we are able to run the whole thing in one shot right now, and then tear it down in the next 5 minutes, and then build it item by item, so that you get a clear idea of how do you do it for your situation, and you can actually generalize it and make it specific to whatever your requirement is. You can modify it. It's very easy to modify. Now, with that, before I run, I would like to ask you, do you have any questions at this stage, or do you, I know some of you are trying it with me right now. So the question I have for you is, do you have any clarificatory questions that you would like us to deal with right now? Because I'm going to execute, and then I will have a new VPC in my Northern California region created for me with a bunch of machines and a NAT device, and all of that will be done for me through automation, and you will see it. Not this wizard automation, but our own Terraform automation. That's what we will be doing, and I will be executing this. So I'll wait for you to ask me if you have any questions at this stage before I hit enter. Anybody? I guess not. So I'm going to hit enter, and you will see that it is doing whatever I just said, which is basically connecting to the Amazon cloud and creating a new default VPC, creating a bunch of security groups, creating subnets, creating a NAT device, putting our key up there. And so the IDRSA key, all of these things are happening right here, right now. And you can see that in this picture. If you refresh, you will see that I suddenly have 2 VPCs. And I have 3 route tables and 3 internet gateways, and all these things are popping up left and right. So let us go see in our AWS EC2 section here as to what exactly is going on in our Northern California region. We have a running instance now, which is going to be our NAT device. It is getting created right now. It is initializing. And we'll also see that we have in our VPC section, we have a VPC created for us. This VPC is called Automated. That Automated VPC is showing up now. And you will see that it has some subnets. So I'll filter by that Automated VPC right now, like this. And then you will see that in this Automated VPC, we have some subnets created. Public subnet is ready. And so the NAT device needs to be up and running before the private subnet will be created. And so you see that this NAT device is already getting actually ready. We are building the NAT device from scratch. We are not using a ready-made AMI in this case. And we are also using a VPN software called OpenVPN here, OpenVPN. And we are including that on the NAT device itself so that we can virtual private network into our virtual private cloud. And this subnet, which is a public subnet right now, we'll have another subnet momentarily, which will be a private subnet, as you will see. That will also pop up in just a few. And so here it comes. The private subnet has arrived. And you will also see a couple of other interesting details around it, such as this route table business, right, that you remember, route tables, you will see that we have, these public subnets and private routes and public routes. Those routes and the subnet association are correctly made. So this is the private route table, as you can see here. And I'll scroll up a little bit. On the other subnet, you will see that it is a public subnet and the public route table. We'll also go and examine the public routes for it. The public route for it is actually going directly through a gateway anywhere on the internet. You can see that. Similarly, on the other subnet, you will see that the routes are not going directly through the internet gateway, but going through an instance. The instance ID is 9247 echo. And this is the NAT device, by the way, that we should see. Go back and compare. On here, EC2, we should see that this device, now we have 3 instances running, by the way, but this 9247 echo, this NAT device, is what we have used in our private subnet for routing. And so this NAT machine is running for us, and all of this has happened all through this automation, which has nicely summarized for us. It tells us that it has created 16 resources and added, and nothing changed, nothing destroyed. And the state of your infrastructure has been saved to the path below. And this state is required to modify, destroy an infrastructure, so keep it safe. And to inspect the complete state, use Terraform show. And the output file, the output state is saved in this location. In that particular file, information is stored about what is created. All these 16 resources that it created, it has saved that information in this file. In the terraform.state file, you can actually see it right here in Atom if you open it. It also tells us that it has created 2 application servers. So one of them is this, another one is this. And it has also created a load balancer for us. It is a automated load for the automated VPC. Automated is a name that I chose. So this automated name is automated VPC. This name is the one I chose in my Terraform setup. It has created a load balancer for us in our public subnet. It has a ELB host name for us. It has a NAT IP address, which is the NAT device, which is this device. It also acts as our VPN device, by the way. And so we have it all running right now. What does that really mean for us? In our cloud, we were able to finish this exercise that we did the other day, like several weeks ago. We did that. We are now able to automate the whole thing through this command. And let us also see the output of this terraform.state TF file. What does it actually contain? So I'm going to open Atom Editor and inspect that TF state file, which basically describes what has been done for us. And in this file, you will see it has saved details about the path, the output, the resources used, like Elastic Load Balancer, and the attributes corresponding to the load balancer itself. And you can keep going, and you will see a complete JSON structure describing what we have in our Amazon cloud, created through this automation that you saw the result of. Now we'll go into deeper and understand how to do it, how to modify it. And I think if I just show you Terraform to begin with, it becomes easy to then begin from this beginning point and make changes as you go along. But if I say that you have this scenario where you begin from just the documentation of Terraform, like something like you go to this Terraform website and say, here is the code for Terraform itself, and go figure it out, that becomes hard. And that is why I think that having this ready-made sample helps you in relating to what you already have done in the previous exercise, and that you can use this as a foundation to modify certain things as you go along building more complex architectural layouts. And so having understood this part, I want to do a couple of things right now. Basically, I want to go back to our code that we have here in our Terraform state. We'll close that particular file. we'll also go and read in our website here as to what the next step that is expected, which is to go visit AWS console, which we did. And then the next step is to tear down everything so we can begin again. And that's what I will do. But tearing it down is also very simple, is Terraform destroy. And this destruction command will destroy it. But I don't want to rush into destroying right now. I want to actually try a slightly different exercise. Right now that we have this infrastructure ready for us, this architectural layout ready for us, what I want to be able to do is slightly different exercise right now, which is not in that write-up. So let us summarize what have we done up until now and what our game plan as a digression is, and then we'll come back to the same exercise. So we are using this Terraform tool. We created a new VPC, and it had all these things that we called out. Also, all of it is done. 16 resources created. Okay. And now what I want to be able to do is, in our resource that we created in our cloud, I want to use a different tool this time, and that tool is called CloudFormation. This is a proprietary tool from Amazon Web Services. It is very similar in its concepts to this tool, except CloudFormation works only on AWS. It is not a general purpose tool. However, in our example, we used open source Terraform tool to construct whatever we wanted to create here. We did all these things, like 16 items created. Okay, great. Now we will understand and compare how does this compare with this guy? That's what I would like to do. And then we will understand this a little bit and then come back to this discussion, which should take us about maybe 10-15 minutes, a little bit more. But then we'll resume our discussion on Terraform. But I just want to give you a flavor of what other people do in this example, a CloudFormation. What do they do in similar setups, in similar situations? So I will play that scenario for you as a digression, and we'll come back to our Terraform discussion right now. So we have created this, and we are leaving it running. Leave it on, leaving it on. So you saw that in our Terraform situation, we began with some sample Terraform code that I gave you, and then we have a design already in our cloud. Now that's one way to use Terraform. In case of CloudFormation, there are a couple of different ways of using CloudFormation itself. And so we will visit this location in Amazon Web Services. Like here somewhere, we will find it in here, here, and here. In management tools, this is where you will find Terraform under management tools. CloudFormation. That's where you will find it under management tools. So I will go to CloudFormation right there and try to read what it actually shows you. By the way, at any time, if you find that my video display does not work or my sound becomes not easy to hear or not able to understand, if you are running into audio or video problems, please tell me. Please tell me. I am running into audio and video problems, but you are not telling me anything. That surprises me. But I just did, like at least 3 times in the last few minutes, I ran into a bunch of audio problems and video problems. But nobody seems to complain.
Audio's been good.
We're not seeing anything over here.
What about video? Is the video going away?
It's fine. The video is fine. Audio is fine.
The only thing I noticed is a little bit jerky, but nothing significant.
Okay. Jerky as in this part of the display or my face? Jerky as in the design in this browser, or jerky in my hand motions?
Yeah, just you and your hand motions.
Yeah, hand motions. Yeah, I am jerk. That's why it is jerky. Oh, that was a bad joke. So let me fix it. I have a fix for that. Okay. So I think it is a lighting problem. I think it is a lighting problem, but we will have to live with the jerk here. As long as you can see the screen, that's what I worry about. Not too much about me. So in Terraform, what we did was began with a starting point, ran that application Terraform apply, and we have a cloud stack, and the entire cloud ready for us with a bunch of things running actually. So we'll go into that detail. But for right now, we are switching subjects a little bit and looking at this thing. This thing is called CloudFormation. By the way, any of you have already succeeded, please tell me that you did succeed, because I think you should be very, very easily succeed in constructing this output. It should be very, very quick and completely automated, because there's nothing to do except put your keys and just run. And that should have been successful for you if you tried it already. Having said, this is very similar tool in its nature to what Terraform did, except they have some fancy user interfaces included. So they have this, there are 3 parts to this CloudFormation toolkit, and those 3 parts are design a template, create a stack, and create a template. So they can be cryptic to understand. So I'll give you my interpretation of these 3 things, the 3 blue buttons. So my interpretation of these things are like this. When you have a design a template, you're basically looking at creating a blueprint from scratch. That is what a template is. Design a template. So you're creating a blueprint that you can reproduce over and over and over again based on this template. That's what this this very first button here, say design a template, basically means, is that you create a template, meaning you create a blueprint that you can iterate over and over on top and reuse that template over and over again. That's what reusable template is, and that's what that idea was about designing a template. In this second step in here, you create a stack. And that basically means that you provide a template into the tool to get cloud, get a VPC. And in the third case, which is this one, which is to create a template from your existing resources, you do the opposite. You have some resources, and you get a template. And so those are 3 things. This is number 3, this is number 2, and this one is number 1, where you design it from scratch. So when you design from scratch, you're basically dealing with a visual designer tool that looks like this, that you have, let's say, load balancer. Let's find out where load balancer is. Load balancing, and you get the load balancer and you put it like that. Then you identify that you want some auto scaling group, excuse me, and some launch configuration and things of that nature. So you basically lay out item by item that you would like to have in your architectural diagram visually. Then you do a file save template, and then you save it like that. Pretty much like a visual editor tool where you file and save it in your local file system, in your local laptop desktop, or you can save your template in a bucket in S3. Either way works. So that was this scenario, where you're basically manually drawing, illustrating, and then creating a template from scratch. That's scenario number 1, which is one way to deal with it. So that's the approach that is step number 1. Or it's not step number 1, it's the alternative or choice number 1 in this illustration, which is when you go to CloudFormation, you see these 3 things. That's what you're basically dealing with. The item number 1 here, this first blue button, is design a template, which is what we just discussed here. The second thing is that you have a template already. You just want to apply the template. And then you get a VPC. But we don't have a template yet. So we have not created any templates for use with CloudFormation quite yet. So we cannot run this scenario. We are not ready for it because we don't have a template. So how do we get a template? That's the third step. We can actually get a template asking CloudFormation to create a template for us. And so what we need to do is we have to have a VPC already and a bunch of resources in there. And so using those resources, we can very easily create a template. And that is what we currently have in our cloud. We have a bunch of resources already created, as you know, here and here, and these 3 machines, and a bunch of other things. A load balancer for example, here. And there are the load balancer instances mapped, and the health checks assigned, and the health checks are actually healthy. And you can see these 2 instances are participating in that load balancer. And so all these infrastructure that we'll discuss momentarily are ready for us. So we have those resources. So we can actually use the tool called CloudFormation right now and use the button number 3 to construct a template based on our existing resources that we have already in there. And so that is the third blue button that I can actually put to use right now because I have a bunch of resources already. And so I will use that. I will actually click the third button. Now, to click the third button, it needs another set of resources to run some code for CloudFormation, and then that machine will actually run separately from your existing resources, and then look at your existing resources, and then create a template. And then that extra machine that gets created will destroy. Let me repeat that. I think it might be a little kludgy or confusing to understand. So here are the set of resources that we have created already. And there were 16 of them, as you saw in Terraform told you. Terraform did this for us, right? That we have it in our US West 1 cloud. That's what we have. A bunch of resources already. Okay, good. Now, what I want to do is create a CloudFormation template. And that is the third blue button. Now, to accomplish this task, CloudFormation needs a separate machine. Separate machine different from these resources. And that separate machine needs to run in your cloud. And that machine will run some CloudFormation code. And that code, when it runs, will look at your resources and then prepare this. And then save this in your S3 bucket. Or give you a copy or something like that. It will just somehow provide you a template. The output will be given to you in some fashion. So this separate machine is to be created. And that is what will run the CloudFormation code. And you can create a separate machine and have it run CloudFormation code by using CloudFormation. And so you have to actually run another template provided to us specifically for this purpose, which is a separate machine that runs CloudFormation code. And that thing is a template. And that template is called the CloudFormer template. That is the name of the template. So in order for us to create a template from our existing resources, we need to use a CloudFormer template to create another resource, like a separate machine, that will run CloudFormation code, and that in turn will then look at our resources and then create a template. And so this part can be a little bit confusing. So I want to make sure that you understand it. I'll repeat that just for the sake of clarity. So from resource, we create a template. That's our goal. And that is the third option, third blue button. Third blue button. From a template to get to resources is the second blue button. In order to run this method, we need a CloudFormer. Now, what is a CloudFormer? CloudFormer is another set of resource, basically one machine, that will run CloudFormation code, and that will look at your resource and create a template and then give you the answer. That's the idea. Now, here, this CloudFormer itself is a template. And so we have to run that template to create this CloudFormer resource, and that will be the second blue button. To get to run the third blue button, we still have to use the second button. It's kind of clumsy to think about like this. But I want to make sure that I now show it to you to help you understand what is going on. So here, I'm going to hit the third button, which is to launch CloudFormer. And that is a step to actually create a stack. This third step is actually going to also create a stack, but for just the CloudFormer thing, for a specific tool. And let us read this so to clarify. So this three buttons, the third button is what I want to click. I want to read about the third blue button, which is to create a template from your existing resources. If you already have resources running, CloudFormer tool can create a template from your existing resources. This means you can capture and redeploy your applications you already have running. Great. To do this, launch CloudFormer and create a CloudFormation stack that runs the CloudFormation tool. And after the stack creation is complete, navigate to the CloudFormer URL available on Output tab. Okay. So that's what they're saying, is that we will create more resources. And that is okay. So we'll go to Amazon console page again and look at our machines that we have running here. We have 3 of them. And those 3 are running right there. So we'll leave them running. That's what we want to capture information about, the VPC, the subnets and all that. And what I would like to do is go back to our CloudFormation tool and then actually click the third button. The third blue button is to launch a CloudFormer tool. So click. And here you see that it says select a template. But I thought you are going to create a template. Why are you asking me to select a template? And that's the confusing part that some people run into. But I think you understand. If not, stop me. This template is a predefined choice for CloudFormer template. As you can see at the very bottom here, it's the CloudFormer template. And that is what is getting created. When you hit this create button, next, it is actually going to create a new machine in addition to the one you already have here. In addition to whatever you have, it is going to create one more. It will be called the CloudFormer. And we have to give a password and a username. And so we'll just give some password, very complex one, and a username, and then create in the default VPC. We just leave it running in our default VPC, so it will be a different VPC than the one we have in our example. We have these 3 machines running in the automated VPC, as you see here, automated VPC. But our CloudFormer stack, we want to create in our default VPC. This setting will control if the CloudFormer web server will launch in the default VPC or if a new VPC will be created, or if you want to launch into existing non-default VPC. So we want to use the default VPC for this purpose of CloudFormer. And we have chosen a password and a username, and then we will proceed forward in going to the next step, which is, let me just quickly check. Here it is suggesting that we have to have a key pair and a key and a value. We don't need to set anything here. And I will then go to the next section, which is where we have these review page. On this review page, we have chosen to run our CloudFormer template. This one. This, by the way, is a JSON template, as you can see here. It's the template to design a CloudFormer machine. That's the estimated cost for this is going to be about something like estimated cost is about $49 per month. I don't think we ought to run it for the whole month, so I don't worry about it. We have chosen the name CloudFormer and a password and a username and all that. So with that understood, I will acknowledge that this will create resources in our cloud. I acknowledge that, and then I will proceed to creating this particular CloudFormer toolkit. It will actually create a new machine, by the way. You will see that happening in here. A new machine will pop up right on this page. And that machine in our Northern California region will be in a separate VPC, by the way. And the creation is in process. So you can see that it is creating these things. The CloudFormer itself is getting formed. And then the CloudFormer will run on your cloud. So let's clarify that again. So we have some resources. We want to create a template. So to do that, we are running CloudFormer tool, so CFormer tool. And to create this tool itself, we are using CloudFormation template to create the CloudFormer. And that is what is going on. And then once this CloudFormer gets ready and running, it will then look at your resources and then create a template and give you the output. This CloudFormer is going to be a web service that we will access. So that is what's going on right now, as you can see in this chart. Was this CloudFormation a little bit difficult to understand, or was it is it clear now in terms of how it actually gets used?
Okay, Nilesh, this is Salam. How are you doing?
Hi.
Do you hear me?
Yes, yes.
Okay, I have a couple of questions. This is the first time I have seen Terraform, which is amazing. As far as Terraform, yeah, I saw you create net devices, load balancing.
Yep.
And whole deal in one, you just click in one button and create all those.
Yeah.
And if I want to, tailor, like, if I want to create a simple virtual machines, like, without NAT, without any load balancing, anything. So what should I have to do? I just want to understand. So where I can go to change those things in order to create, like create from the beginning.
Yeah.
Depending on. So that's on questions I want to know.
Yep.
But CloudFormation I did use before, which is understandable. And, but code-wise to change it is kind of cumbersome that I understood. So it needs a lot of practice to really digest it.
Yeah, it is not really cumbersome. As you will see, once I describe this Terraform to you, you will find that Terraform is actually pretty darn easy to understand. It can be daunting to just look at the whole thing to begin with when you don't have a example to work on. So in our case, we have an example. And by the way, this is not just some other random example. It is exactly what you have done already by hand. So you know the thing already. And
I know. Yeah, this is unbelievable. It's amazing. I know I did it. I did a couple of times, but still it's not accurate.
I know.
Yeah.
So, even when
you saw that. Yeah.
So many things to deal with it. You just tend to forget one little thing and the whole thing.
And this is makes life so easy. It's unbelievable. Yeah.
So what I will do as soon as this CloudFormer tool finishes, that we'll go back to Terraform, and then we'll basically start pulling hair on Terraform, like really understand the nuts and bolts.
Sure, take your time. So, okay.
It is not that difficult. You actually find it is very, very easy to understand. Once you see me describe it, and I will play that item line by line. I will execute that section, the whole Terraform thing, item by item or topic by topic. We'll run it one topic at a time for you to see it, what's going on, which file deals with what portion. And once you see me running it interactively, one item at a time, you will really, really understand. And I'm waiting.
Okay.
I'm waiting for that. Just this CloudFormation comparison I wanted to do. Let it finish. And so we are seeing that it is doing something right now. And let it. It takes time. It is. Yeah. If it takes too much time, I will break it. And because all I really wanted to accomplish is to give you an idea about the comparison differences between what CloudFormation is and how does it compare and contrast with Terraform, which is a agnostic tool, open source, applies across a variety of cloud providers. And so that is the scenario I wanted to make sure that you get. And we will get back to Terraform very, very quickly as soon as this guy. If this thing doesn't take too long, I'll maybe give it a few more minutes for it to finish. But if it does not respond, I will just kill it. You know that.
To me, it seems like Terraform is much easier, and then we can deal with any other cloud company.
Yes, you can.
Yeah, it's better to learn Terraform. In my case, like.
I think so. I think that is I would generally say it is better to learn an agnostic tool that applies to any cloud as opposed to learning one tool that applies to just Amazon Web Services. Because if you just know this one tool, that it only works with that cloud, and then what's the point, right? The point is defeated. Basically, you are stuck with that cloud. And I don't want you to stuck with the cloud. I want you to be having that flexibility to choose whatever you want. And that is why I always suggest that we stick to agnostic, neutral, vendor-neutral tools that do not lock us down.
Absolutely. Yep.
That is what is this tool is still creating in progress. So here is what I'll let it run. I don't care about it anymore. But we'll come back to it. I'll not destroy anything, just leave it running. We'll just use a different region, and we'll leave that cloud running as is, right? Completely as is. Don't worry about it. So we'll leave CloudFormation tool running in the background. We'll, in some time from now, I'll come back and see what's going on. But it is taking its own sweet time, so we'll ignore it. Or in my language, I should say, we'll pardon it. We'll pardon it and go ahead. So what I will do now is let us dissect back using Terraform. Let's understand item by item and play it this time with a different. So in short summary, Terraform we built something in our EOS East 1. And that VPC is created and running and all nice and happy. And then we are using CloudFormation to capture this in terms of an output that we want to save and apply again in the future. That is going on the side. And now what I want to do is leave all of this and not touch this at all. Do not touch. And I'm going to run Terraform again. But this time I will run in US. Was it US East 1 or West 1? I think it was West 1. Sorry. It was West 1. So I was in Northern California. So I will leave it running there, not touching it. And I will run the same tool, this time in US East 1. Okay? That's my game. That's my plan. And this time when I run it item by item, like really small steps, baby steps. One thing at a time, and then go back to see what's going on, come back here and run it again, the next thing, and then build the whole thing so that you understand how to deal with more complex things. That's my game plan. So we'll now begin dissecting item by item and go steady, but slow, and a different region. Not east, not west. We are not touching Northern California. We are not touching it. Leave it alone. Leave it.
Okay.
Okay. We are going to play the same tool in a different region, which means I need to close out on these completely and even come out of the folder and then clone again, right? I'll do a git clone again. And just like I'm doing, at the beginning of the session today, when we began doing a git clone, like somewhere here. Okay. Here. So here it comes. I'm cloning it. And I have this long name that I have now available, this long name. And I would name it something shorter. Like, for example, I will call it Virginia, because that's where I would like to go, Virginia. So short name, I'll go inside the folder Virginia, and then here I have the same tree structure as you saw before, which is we have a folder called Terraform inside the Virginia folder. We have a Terraform folder, and we need to edit this file, which currently contains, change this. Oh, sorry. I need to go to the Terraform folder, and then we have that file called terraform.tfvars, which says, change this. So I can very easily change that. What I need to do is just grab the copy that we already have in another folder. We have it. So I'll remove this file, and I'll say that, you know what, copy from that's what we did. We just copied that thing from the other folder that we are working in the east, on the west coast. And now we have the content. We just copied the same file locally, right? From the other folder, we copied it here. So now we have it. And it is active key already, so it should work. Except now I want to actually study it item by item. So I have these files, a bunch of them. And what I will do, first thing, is get rid of all of them. So what I'll basically do is open the folder that we have here. And let's go to that Virginia folder we have created, which is this one. And then the Terraform folder inside. And let us get rid of a bunch of these files and move them away. So 1 and 2, I'm basically moving them all inside a hold folder. There's this hold folder, right? This hold folder. I'm going to move these things away so that they don't get applied to Terraform when it runs. So it is basically being hidden from view from Terraform. And I'm leaving only 2 files out. Those 2 files are terraform.tfvars, contains our credentials. And this file contains our credentials. And this file contains some variables that we want to define. And I have moved all other files in the hold folder. As you can see, this hold folder is a temporary holding location where I'm moving these things out of my working area. So in our working area, we have just 2 operative files, one containing credentials and one containing variables. So it becomes easy for us to look at one thing or small set of things at a time, as opposed to looking at whole bunch of daunting code. I don't want to scare you with code. Code is not scary. Code is actually beautiful. If you look at it one small piece at a time, you will understand it. And the moment you understand, code becomes beautiful, not daunting, not scary. With this, let us also understand what these things contain, like bin and cloud config. What do they contain? Let's go inspect. So this bin folder contains some files to run our VPN setup. And so these 4 files, we have to run it one at a time to set up our virtual private network. We will go over that later, not using that right now. So go back again. In our folder, we have a file called cloud config. Let's go see there what it contains. And in our cloud config folder, we have a app.yaml file. We'll have to read that file because that contains some configuration to execute on the machine that gets created inside the VPC when you run this whole tool. So that machine creation configuration is in this YAML file. We'll read that also. And then out of that, back in our folder for Terraform, we have the tfvars file, which contains our credentials and the variables file, which is what I want to now open all of this in Atom Editor. So now Atom opens. And in Atom, what I want to be able to do is, give me a second, I'll just change a little bit of settings to make it easy to read. That's what I'm doing right now to see if I can find it. I cannot. Hold on. Let me find a couple of tweaks I want to do to Atom to make it easier to read. So give me a second. Let me do a cheat sheet. I'm not able to find it, so give me a second. I'll adjust the size. It's a preview font size. Okay, font size. How much? 20. Okay. So I'm just adjusting the size of my fonts so that you can see from a distance. That's what I just changed. So you should see that now I have Atom a little bit better than what it was before. So you can see that this whole folder contains all these files that are hidden from view. And there we go. Maybe this is better. So on the, it's still not good for me. Hold on. So yeah, you see that I have modified this whole folder, and all these green items that you see that were sitting outside in the Terraform folder, I have basically moved them in the holding area. That is where I'm hiding it away from our execution so that when we run Terraform, it should not see anything in the hold folder. And so it will simulate as if these files do not exist. And then we'll study one file at a time, bring them in the main folder, and then play. To play that we will actually understand what is going on. So right now in our what did I just do? Okay. So no, still not good, still not good. Okay, go side by side, please. Side this side, and you go that side, like this. Nice. Okay. So right now, as you see in our Terraform tfvars file, we have our access key and secret key stored. In our variables file, we have a bunch of variables defined, which is AWS access key, which is the value we grab from this file. A secret key variable, which is also grabbed from the other file. We are defining our region. In our region, our default is US West 1. I will make a change here right now to go east. And that change I did to go to Virginia. And I will save it. Then we have to have a VPC CIDR. This is the CIDR block that you identify what kind of address range that you want to assign to that VPC that we are creating in Virginia. And the default values I'm selecting here are defined in that line number 16. Next, we are defining the CIDR for public subnet, which is in line number 21. CIDR for private subnet in line number 26. So basically anything that you would do by hand as you go along building whatever you want to do in Amazon's console, you're defining those values in this particular file, and the syntax is what Terraform describes and prescribes. If you go back to Terraform website and look at the documentation, you will find that this documentation is available for you already. You can see the configuration, how do you define the configuration, and how do you select a provider that you want to deal with. In Amazon's example, they're giving you how to use. The example usage is provided, authentication methods are provided, and I have basically taken that segment from here and included in this code. It is a totality of 37 lines, not too long. And in here, we also have this US East 1 AMI line number 35 defined. And that machine image, we are able to get that machine image ID number from this Amazon location. Oh, the creation completed on CloudFormer, by the way. So in Amazon EC2, what we have is we have to go and go to AMIs and select the Virginia location, and then you select and launch an instance that you want to launch. So you go to launch an instance, and that's how you can get the AMI number by looking at the AMI ID right there. This is where you will find the AMI ID for Ubuntu. The number I have for Virginia is 2 Delta 39803. And in my code, line number 35 is the same AMI ID. That's where I got it from. And you can select the AMI ID to match your region. And that's how you select the region you choose in line number 11. The appropriate AMI ID has to match from that region. And that's the tricky part in this particular file. Having said that part, I'm going to close this file and now just see what Terraform will do when I run it. And you can actually run Terraform without actually executing on the Amazon cloud by saying, Terraform, what is your plan? As opposed to apply, say plan, show me the plan, and it will show you the plan. Terraform, what is your plan? And it will tell you that everything is up to date because there is nothing to do, because there is no difference between what you have called out and because you haven't actually said anything right here, and the just variables are defined, but you haven't actually expressed anything specific quite yet. And now at this stage, we should be able to pick one item at a time from these green items and bring them back to our Terraform folder and see what actually it does. So a simple thing that I want to show you is this file, which is the AWS VPC definition. And I'm going to take this file out from the hold location and put them in the Terraform folder. So now in our hold, we have this file back where it was. And you can see that in this file, there are 15 lines of code where we are defining our access key and secret key and the region. And these are already defined in the variable file, by the way. But what this does is defines our VPC. And when we say resource AWS VPC, for the CIDR block, we defined already in the variables file, enable DNS host names true, and tag it with the name automated. So basically this segment, line number 13, says all the way from 9 through 13, 9 through 15, says create a VPC by the name automated and choose the values I have defined in the variables file. So in our variables file, which is the other file there, as you see, this file is where we define the variables. But then in this location, we are saying, go create a VPC. Call it automated, by the way. So let us see in our Virginia region, do we have a VPC called automated? I don't think so, but we'll check. We have a VPC there. In Virginia, there are two VPCs. One of them is called Badal, which is the one we created by hand, if you recall. So I'm going to delete that Badal VPC. We don't need it anymore. And so it goes away. And it will go away. And so the other VPC is the default VPC. And as I told you earlier, do not delete the default VPC. Do not ever delete the default VPC. Otherwise, you have problems. You have to call Amazon customer service. So we do not have the automated default VPC in our Virginia region. which means in our Terraform plan, we just examine, hey, tell me what my plan is going to be for the content that I have now defined, which is just this one file added called aws-vpc.tf file, which defines, hey, please create a VPC. That's it, nothing else. That was that file that I moved back from Horde into this location, which is now available to Terraform. So our plan should be something interesting this time. And so it says, yeah, I'm going to create a VPC for you. It will be called automated, and everything else is computed, meaning the network ACLs, the security groups, and all the other variables that are defined will be computed, except there's going to be one tag, and it's going to be called automated, and the CIDR block will be this. That's what we chose in our variables definition. And so it says, my plan is to add one, nothing to change, nothing to destroy. And so this is the plan scenario. I can just quickly run Terraform apply. And what do you think it will do? Anybody? If I just run apply, what do you think will happen? It will do one thing. We get a VPC, right?
Create a VPC, right? Yeah.
That's it. That's the only thing that will happen. And then it will finish. So I will apply, and it will say that I created a VPC. We'll go check it and then come back and see. So it is going to do that, creating a VPC right now. Here it goes, creating a VPC. And it did. It said, I created one added. And so let's go check. What did you add? So we should see our Virginia region and refresh to see the automated VPC right there. There it is. And the CIDR block and all that is already taken care of. So we are able to create that VPC through code. Now at this stage, I will take a pause at this CloudFormation, take a pause at this exercise and just quickly examine what did CloudFormation do for us, because it seemed to have finished. So digressing again, we are going to go to Northern California and look at our CloudFormation, which seems to have succeeded. And so this CloudFormer stack is now ready. So it's a new stack. We just have to run this stack to see our result. So if you recall our prior discussion on CloudFormation, we have a bunch of resources in our California region. We want to get to a template. To create this template, we need a CloudFormer machine. To create a CloudFormer machine, we are choosing a template to create a resource, which will run this tool. And when this tool runs, it will look at the resource that we already had to begin with, and then create a template for us. And so this has succeeded in building itself, which means we use this template to create a resource called CloudFormer, which is now available to us, and we have to go and inspect and run the tool on this location, which will then look at our resources that we had to begin with, and then give us a template output, the CloudFormation output. That's what we will see when we go visit the Former tool, the CloudFormer tool. And so let us go see, what does CloudFormer tell us? It says the create is completed and all that good stuff. Let us also see the output section. It says you have a URL to visit. So here is the URL for you to use for CloudFormer. And so we are going to use that link. And that's the custom VPC website URL for us, given to us. Basically, it is a machine running in our Northern California region. There are now 4 instances running. 3 of them are from the other example that we did on our own. But then this new machine here is a T2 medium, is running and is actually the one that is the CloudFormer tool. And it is, by the way, not in the automated VPC, by the way, as you can see here. It is created by CloudFormer. The security groups will tell you that. You will also see that this machine is actually running CloudFormer tool. And so we want to use that machine and run the tool itself, which is available on the output page. And then you can actually go to that same site on this public DNS address also. But I would rather go back to our CloudFormation in the Northern California, look at CloudFormer and read its output. And that link is what I should click. And it says, I want to use a certificate. So I'll say, fine, use my certificate that I already have here. And then it should show me a website. This website is going to expect me to provide a login and a password that I chose at the time when I created that CloudFormer itself. You remember that I chose a very simple password, which is what I will type. As soon as this machine decides to respond to me, I will be able to type my login and password and then visit the CloudFormer tool. And I'm waiting, which I do not like. Yeah, okay. It sucks. So back here. I don't know why I do not like waiting. I don't think anybody likes waiting, but yeah. So in our example, we were able to back to Terraform, by the way, because that thing is just destroying me. It's still not opening. I'll give it one more try, but then I'll give up. Okay, come on. You should let me copy your link. I'll go through another door, the back door. Let's go to the back door. This is bad. So close it, open console. We'll go directly to the machine itself. So EC2, we have a Northern California region. We have 4 dedicated instances. And this CloudFormer tool is running on that location. We'll grab the public IP address of that location and then open it. That should open. Oh, oh man. You told me it is successful and then you're not opening it. What's the deal, man? It told us that it is succeeded in creating whatever it did. Did you see that? I thought I saw a success message, create complete. And it is not opening. How crazy can that be? Okay, I formally give up on CloudFormation. Well, leave it running. I'll go back to here. Terraform. So you saw me that there are a bunch of files hidden away from the main folder in a hold folder here. And in that folder, I'm hiding some things. I'm going to put the next item out in the main folder and understand it and see what it is going to do for us, and then play it, see the plan, and then apply it. So you've seen at least one by now. You've seen me do this AWS VPC, right? This VPC we created. We brought that file out from the holding area into this location. And that is what this file contains. It defines a AWS VPC resource. I'm going to close that file and leave it there. But then go to the hold area and look at some other interesting things. For example, I want to create a public subnet, right? I have a VPC, so I want to create a public subnet. So why not I take a public subnet file out into the main folder and drop it there. So my hold folder, I'll close, but then I have this new file open in my main folder, which is going to describe a public subnet for me. Let us read this. So again, very simple, not complex at all, not complex at all. In this file, in the public subnet, as you remember from your hand manual exercise, you need a gateway. So we'll create a gateway in line number 3. Line number 3, which is specifically this line, I am going to create line number 3, get me the VPC ID for the VPC that you already have, that you already know. Terraform, you created a VPC. So get me a VPC ID. And in that VPC, get me an internet gateway. right? Internet gateway. You want to create that internet gateway, which is going to be in our Virginia region, in our VPC. We have these two VPCs, by the way, one of them called automated, which is what I want to filter down. And then look at, do we have any gateways? No, we don't, which is expected. It's not there yet. So we want to create it. So I'll create that gateway in this section here at the very top, lines 1, 2, 3. Specifically line 2, 3, 4. It creates an internet gateway for public subnet. And so that is that portion where I'm saying that, you know what, please get me an internet gateway and also create a public subnet for me. Do we have a public subnet already in our selected filtered by VPC? We are selecting filtering by automated VPC. Do we have a subnet? No. Do we have route tables? No. Do we have a gateway? No. Anything else? No, except there's a default option set available. So there are some defaults already made available, but do we have an Elastic IP? No. Do we have a NAT gateway? No. Peering connections? No. Basically nothing. It's empty. So we want to create a public subnet right in that section, and we can do that very easily by this file. Let us go read further, deeper. And the section, which is the next one, is line number 7, which is this line. That's where you see the number 7 there. And the line number 7 all the way through line number 15, we are going to construct a public subnet. If you read the lines here inside, specifically line number 8, it tells you which VPC to use to create the subnet. And we are using this expression, which is basically referring to the default VPC, sorry, the VPC you created Terraform, use that VPC. We have assigned a CIDR block for you already in the variable definition. So in this var.public subnet CIDR, we have defined that variable in this file. Variable public subnet CIDR is already defined as 10.128.00/24. And that CIDR value is what you should use Terraform to create a public subnet for me in line number 9. Availability zone I'm defining, please get me US West 1A. I should correct this to say US East 1A. Otherwise, I will have a problem. As you know, we are working in the, now in this exercise, we are working in the East Coast. So I have to change the availability zone. Next, map public IP on launch. Should I use that as a default option true or default option false? Then I'm also associating a dependency. This public subnet should automatically connect to the internet gateway, and that definition is in line number 12. Any machines, this particular subnet depends on having that public gateway accessible, which I have defined in line number 3 up, right there. Next, I will assign a tag to it and call it public, the name public, line number 14.
Oh, okay, Nilesh, over here.
Yes.
If I don't want a default, so how should I code this line?
Which default? Which line? Which line number?
I'm talking about line number 9. No, yeah, 8, 9, both.
8 and 9. You have to select the VPC. The 8 number is required because you are basically dealing with the exercise. It is not the default VPC, by the way. It is the VPC that you just created. It is not going to connect to the default VPC. It is going to connect the automated VPC, like this.
Automatic, whatever the VPC is needed for this particular instances,
yes,
they will go and create.
This VPC that gets created when you're selecting this one. It is not going to the default VPC, by the way. Don't get confused by the word default here. This is AWS VPC default ID. It means go to this AWS VPC file and look at its ID.
Okay.
Okay.
Okay. Got it.
This thing does it. It actually going to refer to this VPC here. So it is not going to the default VPC, but the automated VPC.
Okay. This code will does it.
Yep.
By this way. Okay.
Go to the automated VPC already. Next is our routing table for the public subnet. When we have a subnet, we also want to create a routing table for it. So we are saying, please get me a routing table for public and associate with the VPC that we are talking about, which is the automated VPC, which is the same thing here, not the default VPC, but the automated VPC. We are saying that, you know, in our routing table, you assign a route that goes to anywhere on the internet, 0000, and use the gateway ID that we have created up in line number 3. That is this line number 23. Line number 3, line number 23, same thing. Line number 3, actually line number 2 is getting us this gateway, and we are using that gateway in line number 23. And there is one more thing to do in your subnets is to associate with a particular, associate a route with a particular subnet. So we are making this routing table, associating that routing table with the public subnet. So the public subnet that we have created here in line number 18, 19, we are taking that reference in line number 29. We are saying that, you know, for line number 19 that we created a subnet for you, sorry, in line number 7, we created a public subnet for, you created a public subnet for us here, use that as a association for this routing table that we are creating right now. So this section, 6 through 16, it creates a public subnet, and 18 all the way down creates a routing table and gets associated with the public subnet. With that in place, what I want to now do is make sure that we do not have any West Coast references. So I have East Coast references. I will go quickly search for West. I don't have any result for West, which is nice, which means that I have made edits to the West Coast. And now I should be able to go back here and say, Terraform, what's the plan? It says, let me go and check. It actually connects to the VPC in the cloud right now and identifies that, you know what? I need to add 4 more things right now because you told me that I need to create a gateway. I will. You told me I need to create a public route table, which I will. You told me I need to create a public route table association with the public subnet, which I will. And you also told me to create a public subnet, which also I will do. And I will do that in the East 1A with this CIDR block and map public IP on launch true, give it a tag called public, put in this newly constructed automated VPC. We'll have a table association with this public subnet ID. We'll also have a route table defined with a 0000, go anywhere you want to connect to using the internet gateway that is getting created here, by the way. And so these 4 things I will create when you run Terraform apply. So I will now run apply on this plan. But before I run, as you know, in our example, we do not have any subnets, no route tables, no nothing yet, and no gateways on our automated VPC. We do not have a gateway. We just have one default route table that we will not use. So this route table that we have is given to us by default. We are not using it. We are going to go filter down to automated VPC, and you will see that in our VPC, we have this one automated VPC, 0 subnets, 1 default route table, no internet gateway, and that's the current state. We go back to Terraform and say Terraform plan. It showed us this plan. We'll now say Terraform, go apply the plan. It will go and do it for us. It is going to do it right now. We'll go watch the fun here. And here you will see, when I refresh, you should see a gateway. There it is. It is attached to the VPC already. It says attached. You will also see that it created a subnet for us called public. And you will filter down to the automated VPC, and there is one subnet called public. You will also filter to the route tables, and you will see that there is this route table created, which is associated with the public subnet already. As you can see, the association created. You will also see that the route, this particular route table has a route defined to go anywhere on the internet as you like, using the gateway ID EBE55, which is this gateway ID EBE55. And that is what it did. It successfully did, and it told us that I completed the apply function. I added 4 resources for you. Nothing changed, nothing destroyed. And I'm ready to do the next thing. In the next thing, I will go and look at my hold file again. And this time, I'll add further next element. What I want to be able to do now is to actually create a private subnet. But as you know, a private subnet, I want it to connect through a NAT device. And so I will need to have a NAT device first. And then if I want to create a NAT device, then I need to have a key pair, like IDRSA key pair already, which I don't have. I need to first deal with that part before I can start a machine. And so I need to first thing first, create a key pair. But then that doesn't actually help. We also need to have a security group defined so that it will allow us to connect to the appropriate machines using the key pair. There are lots of things now are interdependent that you should watch. And so what I'm going to talk about this up until now in Terraform example, what we have done is created a VPC, yes. We created a gateway, yes. We created a public subnet, very easy. But not really, because it needed a dependency on internet gateway and also another dependency on a route table called public. So we created them also together, an internet gateway and a public route table. And this route table has a route through the gateway, and all these things are needed for the public subnet to exist. So we did these things together in one collection. And this gateway was used here. This route table got created. It has a route table to public subnet association mapped correctly. And it has a route defined from this routing table through the gateway out to the public internet 0000/0 that you saw already in this location. The subnet is available, and the route table shows you it can go anywhere it wants to through this gateway, which is now active. Now, what I want to do next is, in order for us to create a private subnet, we need to have a NAT device. To have a NAT device, we need to have a machine created. The machine needs to be having a key pair, like IDRSA. And also, you need to be able to connect to the machine, which means we need a security group. So security group has to be done, IDRSA has to be created, a machine has to be created, converted into a NAT device, and then we can create a private subnet, which will have its own private route table and a private route. And this route will go through the NAT device. So these are dependencies that we need to worry about. So you cannot just randomly start creating a private subnet, because if you do, watch what happens. If you just take this private subnet and say, you know what, take this private subnet and move it out of the holding area and drop it there. And now we have this private subnet defined. And by the way, this private subnet says west. So I need to go change it to east, which I just did. Save it. And then you have this private subnet defined in this section, and a private route table defined in this section, and the association defined in this section. So 3 sections for the subnet itself and the corresponding route table. So if you have it like this and you try to run the plan, it will complain. It will complain that, you know what, I don't have a NAT instance yet. I cannot run it like this. So you say, okay, let me get the NAT machine out. So NAT, you come out. And you try to see the plan, it will still complain that, you know what, I cannot start a machine because I don't have the security group and the key pair. So you see what's going on. You see that there are dependencies already called out. So you cannot just magically run a NAT server. So I'll put it back in hold area. I'll put this private subnet back in the hold area and just stick to what we were ready with. So in our example, we should just go back to how it was and actually include the dependencies first, like these things, security groups and IDRSA key pair, create a machine, create a NAT, before we jump to creating a private subnet. And that is what we need to be able to do. So in our example, we have moved those things back in the holding area, which means we should now run plan again. And it should tell us that, yeah, no change, because we did not change anything, right? It will run, it will connect to the cloud and figure out that you already have anything. So there's no change needed. So nothing needs to be done. So it does nothing and then comes back. Next, what I want to do is understand this dependency map here clearly. And so create security groups and put the key in place. And then that key that we have IDRSA that generated, that key doesn't exist in our Virginia region yet. So if you go look at my key pairs, I have 0 key pairs, which is good. So back in here, from the holding area, let's get the key pair out. Key pair is very simple. It says, go grab the IDRSA.pub and give it to Amazon. So we'll take that key pairs.tf file and move it to the main folder outside and minimize the holding area. Look at the key pairs file again. In line number 3, you will see it exactly does what I just said. Go to the file called IDRSA and give it to Amazon. And by the way, call it automated VPC. That's the name of the key. And so now, the name of the key is, I'm calling it deployer key, but you can, that key name will be automated VPC. That's what the name you will see in Amazon console. So in this 3-line code, you're basically taking your IDRSA key and giving it to Amazon here. So we'll say Terraform plan, show me what's your plan. And it goes to the cloud and sees that the cloud doesn't have your key. It will tell us that I'm going to create a key. And so it says, yeah, +1. This green item is say plus. Green is addition. So there's a 1 to add. It's going to add one thing here. And what is going to be added is a key name called automated VPC, which includes my IDRSA pub file, which is this file here, line number 3. It's going to grab that file and include that in the Amazon cloud. And I will do exactly that by running the apply command. Off it goes. So you should see a new key pair showing up here already as soon as I refresh. And there it is. Not yet, but it's still doing it. So yeah, it now should be there. I'll refresh and you should see a key called automated VPC, and the fingerprint matches my newly generated IDRSA. So now we have IDRSA taken care of. And so our plan has been executed and applied. One added, one resource called the key with this fingerprint added, and this public key included. This public key is my IDRSA.pub. And next, let us see other things inside our hold folder. Other interesting things include creating a security group so that we know what ports we need to open and what should be allowed to access what other things. So that's defined in this security groups TF file. I'm going to drag that file out into the main folder like this. So drag it to the Terraform folder, minimize the holding area, and go study our security groups file. This is, again, very, very intuitive. If you already have done it by hand, you already know what it is. I'm going to expand a little bit. Oops. I think I moved my mouse incorrectly. Let me clear it. And so let me adjust my mouse again. And here we go. So this is a file that is going to create security groups for us in our Amazon console. If you look at our Amazon and look at the security groups right now, we have for our VPC IDE. Let me delete some other unnecessary security groups here. So we have this Docker machine security group. I want to delete that. So go get rid of it just to cut down any confusion. And these 3 are defaults. I cannot delete them. I wish I could, but I cannot. I cannot delete default VPCs and default security groups as such. They're just given to us. So now, I want to create a security group for us in our VPC. What is our VPC ID, by the way? Let's go check the VPC ID. Our VPC that we have created for automated VPC, the ID number is 5 brother Charlie. So remember the Charlie 5 brother Charlie. That's the number for VPC ID that we have here. So remember that's the automated VPC. So back in here in EC2, in security groups, we'll go look at our brother Charlie there. And that's the default security group available. This is the default one. And so what I would like to now do is run our security group.tf file. But before I run, I want to understand. So here, it's not too long. It is long, 80 lines, but it's not difficult to understand. It is long because it actually needs to be long. So you have to call out what is allowed, what is not allowed, from which point. And let's go read those 80 lines. It's not that complex. So let's first thing first, at the very top. Line number 3 to be specific. Name it automated, default automated VPC. That's the name of the security group. Default automated VPC. That's just a name. You can choose whatever name you like. It's immaterial. Description. It's an English language description. VPC ID. Choose the brother Charlie VPC, which is automated VPC we have. That's the ID number. Brother Charlie will be line number 5. Next, ingress. There is inbound traffic. From anywhere, 0. To anywhere, 0. Protocol any, allow for yourself, true. Egress, outbound traffic. Just open the whole thing, let anybody go anywhere outside. And that's the egress reference. So this reference for egress and that reference for ingress is pretty identical to what you would otherwise do when you create a security group by hand. You will call it my security group, and you will have a description here, and you will define some rules for inbound and some outbound, and then you create. And so whatever rules you define for inbound and outbound, these are ingress and egress. Ingress is inbound, egress is outbound. That's what is getting defined here. So you are looking at this name called default automated VPC, the description in that VPC ID, ingress rules, egress rules, and a tag name. Next, we are going to create a default security group for use with the NAT box. So this is going to be used with NAT. So that egress, ingress is defined in this section. And we are going to call it the NAT automated VPC security group. That's going to be the name. In the NAT group, we want to allow port number 22 access for anybody to connect to it. You can limit this further to keep it to your IP address if you like. CIDR block 0000/0 allows anybody to connect from port number 22 as long as they have the key pair, the private key. You can limit this if you like for ingress, inbound access to the NAT machine from port number 22. For ingress, you are also opening one extra port that we have never discussed before, and this port number is 1194. And it has a different protocol for UDP as opposed to TCP. And so what we are talking about is creating a NAT security group for NAT in the automated VPC. And here we are saying add traffic to a specific port like this. And here we are saying 1194. And what does this do? 1194. In our NAT box, our goal is to not only run NAT and connect to it through port number 22 via SSH. So we are opening up this plus. We are also opening up 1194 UDP. This is TCP. we are opening up this extra port to allow us to access this entire cloud through this point through a virtual private network, VPN. We are going to make this box a VPN box. We create a NAT box, convert into a VPN box, and so have it a dual role. We'll have it run NAT and also run VPN for us. And for that reason, we need to have this port open, 1194. And that is what we are opening up in this fashion, port number 1194 for UDP protocol. And that is what this thing does in line number 43. For egress, outbound access, allow everything basically. So outbound, everything is allowed. That's line numbers 47 through 52. And we'll call this particular security group NAT automated VPC. We're also defining one more security group for web access, for web traffic. This allows inbound access to port number 80, as we expect. That is line number 66. We'll also allow port number 443 for HTTPS access, and that is line number 73. And that name for this, we are going to call it the Web Automated VPC Security Group. And that is this particular collection of code, which is actually, think of it as very simple. There are three things. One, we defined a default security group with these parameters for ingress and these parameters for egress. Then we define a NAT security group with these customized parameters for 22 and 1194 UDP. Then we define a web security group for port number 80 and port number 443. So the reason this code is long and 80 lines, 82 lines is because of three security groups defined in a very granular fashion in great detail. It is not that really difficult once you already know what we are doing is we are creating a web security group. And in there, we are opening up HTTP traffic like this and HTTPS traffic like here. That's what we are doing essentially. And it takes so many lines to say that very succinctly. So lines number 59 all the way to 82. This block, 59 through 82, is basically this screen. That's what we are doing. Similarly, the other function here, which is the creation of NAT security group, we are defining a NAT security group in our automated VPC. We are saying, you know what, SSH, great, and then a custom UDP rule for 1194. That's what I want. So you will get it. So this will become your VPN connection. And this 22 is for SSH connection. Port 1194 is classically used as OpenVPN port. This OpenVPN is an open source virtual private network software, which is what we will install using Docker on the NAT box right now. And so you will see that in our configuration already in just a few as I describe it. So this OpenVPN software is open source. It will run and it will establish a VPN connection for us between the cloud and this machine. And then you don't have to worry about SSH tunneling, and the whole cloud is accessible to you as if it is your local cloud, but it is not really here, it is in Amazon. And so that is port number 1194. That's the scenario that we are going to run in this example. So I'm going to close this file with a quick check for anything about West. We don't have any. There is no West Coast reference, which is nice. And I'm going to close out the security group file, go back here and say Terraform, please show me the plan. And it will go to the cloud, find out what the reality is in the cloud versus the plan that you have defined in the code, and tell us the difference. it says, I will do 3 things for you. 3. Those 3 things are, I will create a web security group. I will also create a NAT security group and modify your default security group that you already have. And so the modifications are basically make sure that you are keeping it the way you design it to be. And you will create 2 more security groups for NAT and web. And the result will be, I will make 3 changes, 3 to add, 0 to change, 0 to destroy. And so when I run this, I should see a bunch of security groups here showing up. These 3 are default, by the way, so they will exist. I cannot delete them. I will have to live with them. But then as soon as I run this code here, or Terraform, apply, you should see that it will go to the cloud, create those security groups, and tell us that it did. And when it does, we should be able to go and see them. It is creating them right now. And it completed creating those 3. So we should go back here and refresh. And we should see 3 new, or at least 2 new security groups. It actually shows us 3, which is a default. So let me read what's going on here. 1, 2, 3. So the reason it did 3 is because it did not modify the existing default, but instead create a separate default automated VPC group for us, a default, web automated VPC and a NAT automated VPC. So we now have 3 distinctly created security groups in our listing. Those 3 are web, which will allow us access to port number 80 and 443, and automated VPC. Yeah, this is basically a default for our own that we created in our example. And this allows all the traffic as long as it is inside the VPC. So allow everything as long as the source is within the VPC. It's okay. It'll allow all traffic for inbound as long as the traffic originates from within the VPC. And next, we have 1 more VPC to deal with, and that is the NAT VPC. So NAT automated VPC, this particular security group for NAT, let me make it a little smaller. So the NAT automated VPC will have 2 customization we have done, which is SSH rule 22 and custom UDP rule for 1194, which is going to allow us to connect our VPN, which is OpenVPN. So these 3 creations have succeeded. And we did that step by step. So we should go do the next one, which is go to the holding area. And now we should be able to identify, are we ready to run a NAT device right now? And I think we are. So I'm going to take that NAT device and put that in the main folder right there. And now go study that NAT file itself. In this section, the first thing I want to quickly check is existence of any reference to East Coast, West Coast. No, we don't have any. That is nice. And now let us look at this particular file. The file itself, we'll go line by line. This is going to create a NAT box. And that's what this says, line number 2. Create a NAT box. Use the AMI ID, look it up from the variables file for the region that I have chosen, and the variable that we are going to define is already defined in this file here. The region we have chosen is East Coast. The AMI ID is defined in here in line number 35, which is nice. So back in our NAT server, that's what AMI number will be picked up through reference to look up the variable file for AMIs in the variable region that we chose. Instance type, we're taking a very small T2 micro machine to make our NAT. We are choosing the subnet ID as the public subnet that we have created in our example through Terraform. We are creating our security group that we created through Terraform. We are assigning the default security group as well as the NAT security group. So 2 security groups applied. We are also creating including and using a key pair that we have already provided, which is the AWS key pair developer deployer key name, which is the same that we have provided already in this example called key pairs. And then keep going. We have source destination check false. We want this box to behave like a NAT box. So we have to disable source destination check. And we include that in line number 8. We are going to tag this machine as NAT. And that is the tag name, line number 10. Then we are defining some connection parameters, such as I want to use the username Ubuntu and use the key file ID RSA, which I have it locally on this machine, the private key. And I want to provision the machine when I execute. I want to do a remote execution on that newly constructed box, which is going to be, by the way, not a NAT machine image. We are choosing Ubuntu, by the way, plain vanilla Ubuntu, and converting that into a NAT box. So that is something very different than what we did before in our earlier hand and manual exercise. We choose an Amazon AMI with a NAT already built in, right? Something like this. We chose a NAT AMI already. So it had the NAT capability built in. Whereas in this example, we are using plain vanilla Ubuntu. And plain Ubuntu is not NAT to begin with. It doesn't function like a NAT. So we have to program it to become a NAT. And that is what we are doing in line number 18 and 19 together. These two lines convert a plain vanilla box into a NAT box. We are modifying route table, the IP tables, and allowing masquerading in line number 18, masquerade. IP tables -T NAT -A post routing -J masquerade. This is a fundamental way of describing to IP table software, the firewall software on the box, to allow masquerading. Pretend that you are somebody else when you're not. That's what a NAT is. Pretend, masquerade. And then we are adding line number 19, we are adding the number 1, echo 1, and putting that inside a file. In that file is proxys net IPv4 conf all forwarding. And that putting a number 1 in that file is what we are doing essentially. Line number 19, echo 1 sudo t. This thing will include the number 1 inside that file, and the file name is proxys net IPv4 conf all forwarding. That enables it to forward traffic to other machines. So it becomes a IP forwarder, IP packet forwarder. And that is a comprehensive definition of a NAT device. You masquerade and you forward traffic. Line number 18, masquerades. Line number 19 enables traffic forwarding, packet forwarding. That makes it a router, basically. And these two lines makes that Ubuntu box into a router. Nice. So we got a NAT device there, and this execution will happen on a remote machine in the Ubuntu box after it gets provisioned. So you have a machine that gets started, and this provisioner will go remote execute these two lines, 18 and 19, on the target machine, making it a NAT. Then we install Docker there. That is line number 21. Line number 21, we'll install Docker. One line of code puts Docker in there. And then we'll create a folder to configure OpenVPN. And using Docker, we will run OpenVPN. Configuring OpenVPN and setting it up is kind of difficult. So we are simplifying our life a little bit and using Docker container to run a VPN inside our NAT. So we have a Ubuntu box, then we make it a NAT device. On that same box, we are including Docker, and then inside Docker, we are creating a new container. That container, we are going to execute.
What's the difference? Sorry, excuse me. I have a question.
Go ahead.
What's the difference between OpenVPN and regular VPN?
That's just a name.
Oh, okay.
The regular VPN, there are actually so many different types of VPN that you will see. I'll show you some examples here. So if you go try to set up a VPN, like go plus and say, give me a VPN. And so here are the types, at least 3 supported in this machine. L2TP, which is a Microsoft technology. The other type is Cisco IPsec, is a Cisco technology. And the third is IKE v2, which is also, I don't know which technology, but there is an open source implementation of that available already. By the way, open source implementation for these 3 protocols already exists. Now, having said, these are commercial products, primarily. Not necessarily, but primarily they were commercial to begin with. Like the Cisco VPN is well known, most large companies use it already. And so here it is, Cisco VPN security, and so you have to pay money for it. Instead, if I want to use the same technology, I would use this open source product, which has basically implemented the same in open source. It is called StrongSwan. And this is IPsec-based VPN solution, just like Cisco is. It runs on Linux in open source. And it is also very easy to install. It also comes with a Docker container. And here it is, CloudGenius, StrongSwan. You can use this container already. And so this Docker container called CloudGenius StrongSwan is a ready-made Cisco VPN. It's not Cisco, it is StrongSwan, but it is open source and it works just like Cisco. And so you can basically run Docker pull CloudGenius StrongSwan, and there we have it. I'll demonstrate that in like 5 minutes, but not right now. So like this, there are other open source VPN solutions, and that is one of the famous ones. It's called OpenVPN, which also comes with a cloud solution, Docker cloud solution, and that is what we are actually including in our example here. So in here, we are creating a folder, line number 23, to store our configuration for OpenVPN. And then line number 24, we are starting a Docker container using OpenVPN image. Docker run name OpenVPN data /v. Oh, sorry, this is a data machine. It's not Docker machine. It is to store the VPN data. Line number 24 creates a empty container to store VPN data, our configuration. And then the line number 26 is where it actually creates an OpenVPN server. And that is a separate container. There are 2 containers here, line number 24 and 26. In 24, we are creating a place to store data about the OpenVPN server, which is going to be line number 26. Line 26 is Docker run volume from OpenVPN data. Here, this OpenVPN data is this container. So use the storage from this machine and then run this image from Gosuri OpenVPN. That Docker image is available already. And you generate OpenVPN configuration, use that VPC CIDR, and use the UDP port that we have opened already in our security group discussion. We saw that, and map it to the NAT public IP. So that is what we are basically doing, is this Docker run volume from OpenVPN data to run an OpenVPN container, generate an OpenVPN configuration based on this particular CIDR block and that particular UDP port on the NAT public IP instance. So lots of things in here. It is probably one of the most complex things to understand, but we will play this and you will see it, what it is doing for us as we will execute this. So you will actually get.
Okay, this is Salam. I just want to reiterate the NAT. Remember when we create the NAT devices, we went to the supermarket to get the NAT, where Terraform got this NAT in the same way. They pick the NAT instances from the supermarket, or how they get it?
So we did not go to supermarket. Supermarket is a chef thing. We went to the Amazon marketplace.
Marketplace, okay.
And in
Yeah,
marketplace,
that's what I mean. Okay.
we found a NAT device ready-made.
Right.
So the first time we did a ready-made device. With this automation, I don't want to be dependent on the people. I will just use plain vanilla Ubuntu, make it a NAT and add VPN.
Uh-huh.
I'll create my own NAT. And those NAT devices are constructed with these two lines. Those
okay. It's not that way.
Yeah, 18 and 19, they make me a NAT box.
Mm-hmm.
Okay, 18, 19, NAT box. 24, storage for VPN. 26, get me a VPN server. And we'll understand these details as we run it. Right?
Okay. Okay, I got it. Okay.
Let's move this on the side. And now we have a NAT server definition, which is defined in this particular file, which is going to remote execute these things in line as soon as the machine becomes ready. And so we'll start a T2 micro machine, use those key pair we have already, and that is this new item that I have created. Basically took it outside of the holding area, moved it into the main folder for NAT server. And now I will say, Terraform, tell me your plan. So Terraform is going to show us the plan. The plan will be to create a box. And so it says, I will create a NAT instance, which is not going to be really a NAT instance, but actually an Ubuntu instance that I will call my NAT machine. And in there, I will run some provisioning code. That provisioning code is going to be this code, lines number 18 and 19 to create a NAT. Line number 21 to install Docker. Line number 23 to create place for configuration. Line number 24 to create a container to store data for VPN. And line number 26 to create a VPN server itself, all of them using Docker. Using Docker, you're just ready-made using tools. So that makes it a whole lot easier than creating something out of scratch. So I will now go on this side and say, Terraform, go and apply. And so you will see that this Terraform tool will go and create a machine for us in our Amazon cloud. And so you should be able to go to Virginia and AWS and EC2 and find that a new instance going to pop up here, and there it is. And it is going to become our NAT machine. And then it is pending right now, but it has picked up all the required attributes like automated VPC keys included, public IP available. You will also see that it has picked up our security groups correctly. So let's go check the security groups aspect of it. Hold on. Let me go to the dashboard, running instance one more time. And here we have our security groups, which are the NAT security group, the default security group together added. So we can view the rules. The rules are, I have all access allowed as long as it is within the VPC. And for 1194, UDP, allow from any location, so I can connect my VPN. And port number 22 allow TCP access from any location. That's the location I have defined. These two are from the NAT security group, and this one is from the automated default security group, which is a separate one I have. It allows for within the VPC connection, within the VPC any-to-any connection. We are using the Ubuntu AMI, the plain vanilla Ubuntu. This machine has a private IP. It is in the VPC 5 brother Charlie, which is the automated VPC. It has a public subnet. You can compare that this is the public subnet ID number that we created. You can see that if you go to the VPC section, you can see the subnets there already. And so you should be able to identify that we have a public subnet right now only, and that is the 8 Delta 5. Back in here in our EC2 in Virginia, one running instance. And that instance is actually running right now. And you see that the custom code is getting executed. This code that we have included in lines number 18 and all that is getting run there. You will find that it is probably doing, I think, installing Docker or something. I'll just see. Maybe an apt-get update is happening. But remote exec is what is going on right now. On the remote instance, you can, as soon as you start a machine, you can execute some code if you like. And that is what we are doing. In here, we are running apt-get install, bunch of things. Then we are waiting for the Docker engine to set up. Now it is pulling some Docker images for OpenVPN, and it is still creating, so it is waiting for it to finish the download of OpenVPN image, and then it extracts, it completes the pull, then it generates a configuration. That is the line number 25, 26. And now in that machine, we have completed one application of one resource added. Basically, we now have a NAT box. And not only that, in that NAT box, we have a Docker container running to store OpenVPN data, and another container running to store the OpenVPN server. So how do we check? We can go to this IP address and go to that IP address like this. Oh, wrong IP address. Copy again correctly. Public IP is this, so let's copy that carefully. Back in here, IP address should be this one, and then go connect. It should allow us to connect, no problem. And we are connected. Now we should go do sudo and then say docker ps-a. We should see that there is a container created for us. We'll also see Docker images, that there are these two images, one for BusyBox, which is an empty, very small, tiny image, 1 megabyte image, and the other OpenVPN image already downloaded, available for us. So we see that these things are running. We'll also see one thing here, which is this proxysnet IPv4 forwarding that file. I want to make sure that I read that file. So I'm going to, ouch, made a mistake. In copying, I should copy that carefully. Copy. What am I doing? Hold on. Go back, please. Yeah, please go back. Nice. So I'm going to copy this carefully. I think this is a problem that I run into with control copy versus command copy in Macintosh. So in our computer, we are going to cat this file, and you see that it contains the number 1. That is one characteristic that you will see that is a property of IP packet forwarding. And that is what we created in this line here, line number 19. line number 19 helped us create that IP forwarding configuration, which basically makes this machine a NAT machine. Which is in our line number 19. And we already saw Docker running there, which is what has succeeded. So we have succeeded in creating our NAT box. Now is a good time to create a private subnet, because we cannot create a private subnet without having the NAT box. So we can go to private subnet file, put that into the main folder, and minimize the holding area and look at the private subnet. The private subnet is again very simple to understand. There's a VPC identifier, which is our automated VPC. There is a CIDR block for private subnet, which we have defined in the variables file, which is this CIDR subnet, 128.1.0. In our private subnet, we are also saying that, use the subnet CIDR, use east1. I think that is correct. We want to use east, right? Yeah, we want to use East Coast because we are in Virginia. And so map public IP on launch, we want to say false to it. As opposed to public subnet, we said true to it. Right? In a public subnet, we want the machines to get a public IP address. So we said true in line number 11 for public subnet. For private subnet, I will like to say false, because I do not want to get a public IP address. I don't want a direct connection to the internet. I'll say false. And it depends on the existence of a NAT instance. So you have a dependency called out like that, and then you tag it the private subnet. While you are creating a subnet, it's a great idea to also have the corresponding route table defined. So these lines 13 through 19, 20 are going to create a route table. And then associate that route table with the private subnet in line number 22 and down. Association. This association of route table with the private subnet will happen as soon as we run this code. There's one more thing to notice, which is line number 18. And that is, we are saying that, for the routing table, for private subnet, the private route should go through the NAT instance, not directly through a gateway. You compare that with the public subnet and look at the routing table. For public subnet, you will see that it goes through gateway. So public subnet, it uses the gateway internet gateway already in line number 23. For the route to anywhere on the internet, use the gateway. Whereas in our private subnet, we would like it to go anywhere on the internet, but use the NAT instance. And with that is this discussion. So now I will come out of that NAT machine, which I'm connected to right now, and say, Terraform, show me your plan. And it says, I'm going to create a new private subnet and also create a new route table for private subnet and make the association, and also connect the public route, connect the route to the internet through the NAT device. So it has basically told us that it will do these 4 things. One is to use that NAT instance, make some modifications to it. So it's a plus or minus, some changes happening here. It is telling us that it will change something from security groups 0 to security groups number 2. Then, it's going to add these 2 new security groups. It's going to create a route table private. It will also associate route table private with the subnet private, and also create a subnet private. And when you run these things, you will have these 4 resources added on. So I'm going to run Terraform apply, and it will go and create a private subnet here. In our VPC, we should be able to see it. VPC and 2 VPCs, automated VPC. So we filter that, and we now have a subnet. For public, we have a route table. For only public, it is still running. And it will basically recreate the NAT device because we have to make some changes to the security group ID. So there's a plus or minus indicator here, which basically forces new resource. And so that is what's happening right now. It is creating a new NAT device. And this happens because we are running these things one item at a time. We are including one logical component at a time and building it out. So it requires a cross dependency. So it is going to destroy the NAT device and create another one. That's the nature of the beast, because we have to modify our public and private subnet. We did not create them together. So it is basically doing the thing for us. But since we are doing in this run, doing one logical item at a time, and that is what you are noticing, it is destructing something and then creating another similar thing. And that was needed because we have modified our items from the holding area, we brought them outside. And so you see that this is NAT instance getting created again, another one with a different IP address this time, and that will happen. And you will see that it also gets installed with Docker. It also becomes a NAT device. It is not right now not a NAT device, and that will happen once you finish through this step. And then we will have a NAT box that also functions like a VPN server. So while this is going on, let us see what our Amazon CloudFormation is still doing something or responding to us or not. So back in here, CloudFormation in California, CloudFormer, look at the output and see if you show me something, please. Just say allow. And it says what? Password? Something silly is here. This is not, I'm not going to say yes to it. No. Yeah, I will allow this. Something wrong. No, something is wrong here. Let me try it again. So URL in CloudFormation. I'm killing it. Killing it again. Back to California, CloudFormation. We have that create complete and the machine running in CloudFormer tool. I'll grab the public IP address and open it in a different browser. Let's see what happens. So different browser, opening up the IP address. And it is still stuck. Yeah, I'm going to destroy this thing. This thing is not responding. The CloudFormation thing is not responding. So we'll say bye-bye to it. CloudFormation, you can go bye-bye. It is going to die in a few minutes. And it dies, but it does not kill the other thing because it was created through Terraform. So we have two Terraform folders, one for Virginia and the other for California. So we'll go to the California one also and delete it, but not right now. Right now we have succeeded in creating 4 resources, which is basically creating a private subnet. So we should be back here in Amazon and look at our Amazon console in Virginia area, and we should see that we have EC2 machine running one instance, and one of them was terminated. The old machine was terminated. A new one was created exactly like that one, but with added capability. So the added capabilities are that we have modified our security groups and our our file structure in the code that we have changed. So it basically forced a new NAT creation. Then we also have in our VPC here, we have these two VPCs, and we'll narrow down to the automated VPC, and you will see that we now have two subnets, one for public, one for private. We have three route tables. One was given to us automatically. We are not using it. We are using the other two, which is this one is a subnet connected to the private, associated with the private subnet, and this route table associated with the public subnet already. Let us see the routing for the public subnet. The route goes to anywhere on the internet through the gateway, which is nice because this is the public routing table. The other routing table is going through to the internet, but going through a NAT device. This NAT device is C564. It is active, and it is this NAT device that is now running right now here, and the ID number should be C564. And that is the ID number C564. And we should be able to grab this public IP address and get to the machine like this. And it should allow us to connect. And we should see the same things here, like for example, Docker images and Docker containers that exited, the empty container storing data for about OpenVPN. And that's what we have right now in our cloud scenario. Let's exit from here and back to our folder. We are still hiding two files in there. What are these two things doing? So let us understand this thing. This file, what we want to now do is, first of all, let us draw some pictures to help us really understand what we just did. So I'm going to draw more pictures right now by using a different tool. Come on. Yeah. So we began creating a subnet. We have actually two subnets created, right? So we're going to copy them and create two of them. One of them is called the public, and the other one is called private. We also have created a NAT box, and we did that creation by basically taking a box and putting it here on the public subnet. Hold on. Like this, and created this box. Basically made this box into a NAT box and also a VPN box. While we are doing that, we also created, let me see if we did already or not. Maybe we did not. Yeah, we did not yet. So I would like to make sure that I am not telling you anything that confuses you. So we have created this onto the box, which is running Ubuntu. It was an Ubuntu machine. We have a public subnet and a private subnet. We have a public route table, private route table. We have created a VPC. The whole thing is in a VPC. So this thing is in a virtual private cloud. What else we have done?
Okay, Nilesh.
Yes.
Okay, the NAT we created for the private, not on public though, don't you?
Yeah. We created it on the public subnet because we want these boxes that we will use, right? These boxes that I want to use, connect through the NAT and then go out.
Oh, okay, okay, that's you mean. Okay, got it.
I also have created a gateway which allows this box to go out, right? So the gateway is how it actually connects to the NAT box, connects to a gateway, and that is how it is able to go to
Going to the public, yeah.
internet, right?
Yeah.
So did I miss anything in the drawing that we have done already? Okay, we did not.
No,
We did not create this one yet, so we should delete that. That is not done yet. Yeah, that's what we have. Anything I missed?
yeah, that's all so far.
Yeah, probably not. I did not miss probably. So now I want to do a couple of things. Like, for example, get a load balancer and get 2 more boxes here and here. And have these boxes balance some customer workload. So this load balancer is where people will go and visit. So this person will visit the load balancer to a web browser. So they will access this machine. This is like the traffic cop. And this cop will say, you go here. And you, other people will go here. And more people might go to other machines that will basically get added when there is more need. If you have more demand, you can add more machines like this. Like that. And if the demand is not there, you can reduce the number of machines that you don't need anymore. So that's how you will scale out, scale back in. And that's the kind of scenario I want to now include. So we will do that through this Terraform app servers.tf. What we are basically saying is that these boxes are my app servers. And this traffic cop is my load balancer. Right? And we will use the Elastic Load Balancer service available to us in Amazon. That is what we will do. And as you will see, these things is what I want to actually create. So the new resources I'm going to now create are this, this, and this. So that's what this next step is. It is going to be creating application servers. And I will move that file outside of the holding area into the main area. And this is what it looks like. Let us first thing first check. Do we have anything about the West Coast? No, we don't. Nice. Next, let us see how many lines it is. 37 lines. Okay, and now let us read it. Line number 2. Give me 2 machines. Count number 2. Count is 2. Give me 2 machines. Use the AMI ID number defined in line number 4. Instance type should be T2 micro, so keep it small. Don't get me a long bill, I'm just learning. Subnet ID, use the private subnet. Security groups, use the default security group. I don't want the NAT group, don't want the web group at all. All I want is the default group. And in there, use my key, IDRSA, which is called deployer. Source destination check. I'm saying false. User data. I'm including some user data here, which is a file in the cloud config folder, app YAML here. And that file also includes Docker. So this is going to run Docker on the application containers as well. On the other 2 boxes that we are going to have, where is that drawing here? So these 2 boxes will also run Docker and Docker. And there we will install some application. And that application will be able to load balance among these two as people will come and hit our load balancer. We want to divert that traffic into two different application servers. And those two application servers that I have in mind, I need them to running some application for which I need to have them ready for Docker. And then I will like to install my application, my app, right on top of the machine itself, which will run Docker for me. So I'll just install my app with very, very easy methods that we already know. So we have an application that we just run it here and here, and they will be identical, right? Identical. So they're pretty much the same, except there are two different boxes. That's what I want to provision. And I will use a separate cloud config folder, like shown here, which contains an app.yaml file. And this YAML file is what I'm doing to execute, install Docker, and that is line number 6, install Docker. And line number 8 is run some application. For this example, I'm just using the Nginx application for simplicity. So I'm running Nginx right there inside Docker container on those two boxes. So here, Docker, and I'll add some application called Nginx. Very simply, I can get some example application included with the Docker container on these two boxes, and then map them like this with the Elastic Load Balancer. And so the definition of Elastic Load Balancer is also called out in our app server file, and that's what we'll talk about next. So user data, cloud config, app.yaml is this file reference I have here in the section for cloud config, app YAML, and that's what this app server.tf file will pick up and run those automated app count index, meaning how many machines you have. 2, it will just add -1, -2 to those 2 machines that you create in the private subnet. Line number 6, private subnet. And now we have to distribute load among those 2 boxes that run Docker containers that will run an application. And so those 2 will get distributed, the amount of work that we'll have on those boxes, through a load balancer. And that is creating a new resource for load balancer in line number 17 inside the automated VPC. We are creating a name for it called ELB. And we are using the public subnet, by the way. This belongs in the public subnet, ELB. It goes to the public area because people access it from outside. So you want it to be publicly accessible. And so you need it to be running on the public subnet. And that's what, if a public facing Elastic Load Balancer needs to be sitting on the public subnet. You can have a load balancer. Yes, you can have a load balancer inside here also. But it is not going to be accessible by this dude. You want the dude to access it, better keep it on public. Otherwise, the dude cannot access. So what's the point? So you can create, there are usage scenarios of using Elastic Load Balancer inside the VPC where it is not publicly accessible. And that can be valid scenario. We'll talk about that separately, but for right now, make sure that this is in the public subnet. And that is what this definition, line number 19, says. We are also creating security group associations. So we are using the default security group as well as the web security group, because people will want to hit this machine on port number 80 and 443. So we are allowing web access for the ELB. And so that's what this line is. And we are also including a listener. This listener will listen for port number 80 on HTTP protocol and map it to the load balancer port 80 on HTTP protocol. What we are saying here is that, you know, when people come and visit you, load balancer, they will visit 80. And so I would like you to talk 80 to me, and I will talk 80 to you. That's what we are saying. So you please talk to me on 80. I will respond back to you on 80. So you talk 80 to me, I will talk 80 to you. And so that's what is defined here. Instance port 80, instance protocol HTTP, load balancer port 80, load balancer protocol HTTP. So these guys need to talk to each other. So we are basically saying you guys talk to each other on port number 80. And so that nobody gets confused about who's talking to who on which port. You can actually make this distinction and have this guy talk to 80 and that guy respond back on port number 81. That is also okay. But in our case, we just use this example. You can modify whatever you want. But then if that's the case, you want to run something on port number non-standard port 81, that is possible. You just have to write the application that you will have to actually work on that port 81. And then load balancer will respond on 80. These guys will respond on 81. And that is totally fine as long as your application supports that. In our example, the application responds on port number 80. And so we like them to talk to each other on the same port. That's what we are defining in that example there. Next, we want to do some health checks. These health checks are basically check on whether your machines are still living or dead. If this is running, live or dead, live or dead. So this service needs to do a health check. Health check on what? On these boxes. You have these boxes and you can have more of them, and you need to do this health check on in each and every one of them. If you don't do that health check, you will not know where do you want to send the traffic to. And so if one of them dies, you need to know that they died. So you stop sending traffic to them. So say, for example, this one dies. And I made a mistake. So it will wait for me. And then I will correct that mistake. So it will start responding again. Okay. And I think either this is a bug or a user error. One of those two. I had to learn how to use this tool properly. It gets stuck occasionally. It's still stuck. Yeah. Okay, cancel please. Quit please. And start talking to me please. Oh man. Okay, it did. Okay, finally. So if these machines somehow, for some reason, die, we need a method to have the health check taken care of. So we should say, yes, everybody is live and well, or some of them die. If they die, the load balancer needs to know. If the load balancer is not aware, then that load balancer will send traffic to the dead machine, and you will see scenario which you just ran into in our Amazon CloudFront example. I was trying to hit that particular device, the CloudFormer tool. It is not responding to me, and I don't know what to do with it. And that is a bad scenario of usage. So it just happens that the machine that you created through CloudFront decided to die. I don't know what happened. I did not have time to diagnose it. But what we are doing is making sure that we are introducing health checks here. Health check. And what does a health check do? It basically looks at this machine, every one of them, every 5 minutes, or every minute, or every second, depending on how you configure, and then asks, are you alive? Yes or no? And if the response is nothing, then it is assumed that you're dead. And so somebody will come and shoot you on the head, and you will actually die, even if you're not dead. If you're alive, you need to respond to load balancer on a health check request. If you don't respond to the health check request, you will assume that you're dead and kill you. That's the idea. So in our example here, we are setting up health check threshold of 2, unhealthy threshold of 2, and a timeout interval of 5 minutes, and the target to check is HTTP port number 80. If the load balancer comes and says, hey, are you healthy? It will do that check on port number 80 at HTTP port 80, and you should respond with 200 OK. That will happen automatically. Nginx or any application will do that by definition if it is running. If it is dead or if it is not responding, then in the timeout interval of 5 minutes, if it decides that it is not going to respond, or if it doesn't get a response, load balancer will mark that machine as unhealthy. And that's the health check. We'll also have these instances issue AWS instance ID for the application. So we are assigning instance IDs based on our variable that we have defined here for the instance.app.star.id. And that will create those instances for us and associate that in the load balancer. So we are asking that you, load balancer, I'm creating these 2 instances right now. I want you to include them as your instances that you will listen for. So in our example, now that we have this particular file in our main folder, out of the holding area, where we have only 1, which basically prints out all the values. So I want to actually put this output.tf file also outside, and nothing in the holding area at all anymore. And in the outputs file, it is basically printing out values of what it did. And that is just a summary result. So that I want to keep. It basically putting outputs in line when you run it. So when I now run Terraform plan, it should show me that it is going to create a load balancer, create 2 instances, create health checks, and map ports, and get ready for us when we apply. It will actually execute that scenario. So you see that it is going to basically recreate a NAT instance. It will delete and create a new one. It will have an application instance 1 created. It will have application instance 0 created. It will also have a load balancer created. So you will see these things happening as we execute the apply. It will also modify the private route table. And because that NAT instance is going to change, it will die and a new one gets created. So the route table, public route to the internet, has to go through the new NAT. That needs to change, and existing NAT needs to destroy. So now when we run, say, Terraform apply, it will do exactly what we said. And that is what we are looking at. So while this runs, I will like to now open a new terminal. And in that, we will visit the other Terraform that we have, which is called TF, by the way. And so in the other Terraform called TF, I will like to rename it to call it MVTF California. And now we'll go inside California area and say Terraform destroy. And so, oh, it's not in the right folder, so we should go to the Terraform folder inside California and say Terraform, you please destroy. And so what I want to be able to do is destroy our California cloud completely while the Virginia cloud is getting constructed. So I will say yes to this instruction, and we'll say, California, you go bye-bye, and it will die. The whole stack, including the VPC and all the references and NAT instances and everything else dies along with it, which is what is happening right now. So it will kill the whole thing in the California region, and we'll let it finish. But our focus right now is on the Virginia area where it is creating these new things. So we'll go back to Amazon and see what's going on. In our California region, you should see that our machines are getting terminated. They are shutting down. You should also see that our VPC is getting destroyed. We have 2 right now. The automated one is still existing. It will die momentarily as soon as this destruction finishes. And so it is still destroying the NAT instance and everything else associated with the California region. It is still destroying, and as soon as the destruction completes, it will tell us that it did, and that will be nice cleanup, nice cleanup. That's what you will see in the California region once the cleanup finishes. In the meanwhile, let's go to Virginia and see what's going on in the EC2. You will see that another new running instance of NAT is initializing right now. This NAT instance, it is a new IP address, a new machine. So on the okay, hold on. Yeah, the destruction on California has succeeded. So we can see that it completely destroyed all the 16 things that it created. So we should now go to California again and see that everything has disappeared. All the instances are dead. In our VPC, we should see that the VPC itself is only 1, which is the default VPC, and the automated VPC has gone. Along with it, all the route tables, gateways, everything else was basically extinguished because we did that. And so back in here, in our Virginia cloud, we should now see EC2 instances, 1 running our NAT, and which also behaves like our VPN machine. And I will close this folder completely right now, so I'll quit it. And I'm waiting for the NAT machine to pop up and get installed with Docker, and then get converted into a NAT box, and then Docker gets installed. Docker will run OpenVPN, and all these things will happen right now, so as you will see. And then we'll also see that we create a load balancer for us. We'll create 2 more boxes, pretty much like these 2 boxes. So I'm deleting some of these guys right now. And I made that mistake again. I think it is a bug. Yeah, it may waste my time, which is unfortunate. It is a bug. But yeah, we have these 2 boxes. This one is called app 0. This one is called app 1. And this one is called the load balancer. These are getting created, and they will get connected with a health check and a port mapping. And we should be able to see some Nginx running on here and here in just a few. As soon as the creation succeeds, we should be able to go through, like this user, through the load balancer, go to see what this Nginx shows and what this Nginx shows, and we should be able to see some load balancing action right now. And it has succeeded in creating all that thing. We have a ELB host name defined. And so we should now go to the Amazon cloud and look at the dashboard. We have now 3 running instances. So we have the automated machine number app 0 and app 1, 2 boxes. And then our NAT machine running here on this location. It also runs as our VPN. On these 2 boxes, we have Nginx running. And we should be able to see that very easily by going to the load balancer section. And here we will examine that we have a load balancer running now, and it has internet facing scheme, it is public facing. We have none of these instances in service yet. They are out of service, which means the health check is still failing, which means we should go and examine what these instances are doing. They should be actually put in service, but the instance registration is still in process. It should show us that these two machines are actually in service. And that is what we are looking at right now. So that they're taking its time to finish generating these instances and putting them in service so that this ELB knows that these buddies are available for service. And so we should be able to make use of them as soon as that those two boxes get configured to work with the load balancer. So we will wait for that to finish. It should finish fast, not too long, I guess. In here and here, we will have those app 0 and app 1. We're getting ready and configured to use with the load balancer. In the meanwhile, let us go and examine those two machines directly. Like we will go through our these two boxes. We have them running Docker Cloud, and we have this NAT machine up and running that we can use as a jump box to go in there. Alternatively, if you have a OpenVPN client, you can connect to those internal machines through VPN. If you try to go there directly, app 0 or app 1, they don't have a public IP. So you cannot go there unless you either use a jump box like this or use a VPN. Since we have a VPN, I want to show you the VPN scenario in our example here. We have this binary folder which creates VPN configuration for us. Now, in order to connect to the VPN, we need to run these 4 commands one after the other in that sequence on the terminal. And so let us go do that. In our Terraform folder, we will run shbin/1. Is it bin or what? Am I in the wrong location or what? Okay. So I should come back here and say bin/1, and then execute the first command. What does that first command do? And so this command will execute an SSH connection to the NAT machine and then run Docker, OpenVPN, and initialize OpenVPN PKI infrastructure. Now, for those of you who have not used OpenVPN before, and initialization is a first step that is needed to make sure that we are assigning some initial values to the VPN connection. That is what this command will do, and it is very intuitive. As soon as you run it, you will see it. I'm going to execute this command, and what this will do is connect to the NAT machine and then go inside to execute the initialization of OpenVPN. What we are really doing is establishing a certificate authority. And that certificate authority is what we need to create. You may now create a new certificate authority, and we are generating a 2048-bit RSA private key that is required to create this certificate authority, and we become our own authority so we can give certificates for VPN access to other people in the company, for which we require to provide a passphrase. So I need to give it a passphrase. Right now, I'm giving it a secret word. I'm repeating the same secret word again. And now it is going to ask me this question. Where is your VPN server? do you know? And you can call it, my VPN server is this IP address. You can call it like that. Or you can use the public DNS name if you like. Or you can use a friendly name to this IP address by putting this IP address in a Cloudflare DNS name. So you can put that entry in Cloudflare for yourself, log in, and Cloudflare is basically any DNS server that you have. So I'm just using Cloudflare, but you can use anyone you like. So I'm logging into Cloudflare. It asks me for a two-factor. I'm going to give it my two-factor. Hold on. And the only way I think Cloudflare does two-factor is through Authy, which I have disabled for some reason. So I'm generating that right now and getting my two-factor authentication out from other computer and putting it here, 4995890. Okay, login. So what I'm doing essentially is in my DNS, I'm creating a new entry for VPN. And so I'll search for it, VPN. Do I have any entry? No, I don't. So I'm going to enter a new entry for this IP address and say add a record. And here we go. So now we have a new entry for this DNS endpoint called vpn.cloudgenie.us. Having done that, I can use that name in my command here. And I will say my VPN server is this. That is going to be my company-wide VPN server, which happens to be the NAT box, which is running in my public subnet, which is where I have running this OpenVPN software also. And I'm configuring it with a common name, which I have mapped it to this, this name that I just mapped in CloudFront. So I can dig it. I can say dig, and then vpn.cloudgenie.us should bring up the IP address that I just assigned, and it does. This is the NAT IP address. So now I should be able to use that name as a friendly name for all the employees in my company to use that box as a VPN server for our corporation. So that is the certificate authority I'm establishing, creating right now. And here it goes. It is generating a long prime number, 2048-bit long. It takes about a minute on a small machine that we have T2 micro there, which is really small, but it should finish soon. It is doing it. And so we have a long, safe prime number generated right now. We will use this information as the initialization that is happening. We have basically called this machine as our VPN server, and we are initializing OpenVPN right now. This is going to take a long time, as it says, but it's not that long. I know how long it is, so it should not be too long. It should finish in less than a minute. So that is this step number 1, which we just finished doing, or it's about to finish. Next step, what we want to do is to establish a client. So I'll describe this concept. If some of you are new to VPN, so I'm describing that. So what we are doing in OpenVPN is we are establishing these 4 steps. First one is to create a certificate authority. The second one is for every employee, we need to have a client in the OpenVPN. And then we generate these client-based certificates and then assign them to the individual employee. And then fourth one is you start OpenVPN. Those are the 4 steps we have to do. So in step number 2 and 3, we have to assign a client and then generate a key for that particular individual employee who will use that client. So if you have like five people in your company, you have to create 5 clients. So 1, 2, 3, 4, 5. In our example, we'll just have 1 employee in our company, and we'll create that client and then generate a certificate to use for that particular employee who will then use this VPN infrastructure. So those are the 4 steps that we are running through right now. And the first step is still asking us for a few questions like, what was the passphrase that you created? So here we go. We are going to give it the passphrase again. And then it says, yeah, I did it. So it created a configuration for us. It has stored that configuration in that location inside that machine. And we have our certificate valid until the next 10 years. So this certificate is certified until 2026. And the database has been saved in that Docker container to store configuration, as you know. With that understood, let us now run the second step, which is build EasyRSA client configuration for the client that will connect. So we are basically creating a new client entry, this step. In step number 2, bin number 2. And what we are going to do is connect back to the same server, OpenVPN server. And it is now asking us to, what is your passphrase? We have to give the passphrase again, and then verify it again. And then enter the passphrase for the certificate authority that we have created on the previous step. So this is the passphrase for the certificate authority for step number 1. And now it says, yeah, I created a client and I have it safe on the server, OpenVPN server. But we are on the workstation, CloudGenius workstation here. And the certificate is available on that location in that computer, far, far away from us. So we have to bring it down. And that is why I'll give to this employee. So the client certificate generated, we have to give it to this employee, for which we need to bring it down, like down to this machine. We can do that in step number 3. And what this does is brings down the client certificate. And so again, all of these are command running on Docker on the remote machine. We are connecting it to that machine through SSH, and they're running Docker. And through Docker, running these exotic commands. So step number 3 is going to generate that, gather the generated configuration and bring it down right here. So we have this configuration stored locally. And if you go and read that entry, it is a new file available to us. It says unable to find. I think I forgot something in our step number 2. And the step number 2, I should have executed in a slightly different fashion. And that is that I have to provide a name for this client. So it has to have a name. So the way to run that step number 2 is slightly different. It has to be run like this, bin/number2, and then you have to give the name of the client. Like for example, the client of the employee name can be Nilesh. So it has to have a name. And then you create a passphrase for the user, the employee, and what you just saw me do was creating a Nilesh-based certificate for Nilesh as the client. So I did not choose a name to begin with. That was the reason why we have an empty output here. So now I have chosen that name there, which should bring us the correct output in the step number 3, as opposed to this empty output, which does not have a name. So I'm going to delete that entry right now and try this line number 3 again. This time, we have to gather the client for Nilesh. So I will run bin/3 and say, Nilesh, get me the client certificate for Nilesh, please. So it will go to the container and bring down this Nilesh certificate like that. And this certificate will contain all the credentials needed for us to use OpenVPN to connect to that remote cloud in a virtual private network. In that OVPN file that gets downloaded here, we'll go study what it contains. Lots of things here, lots of things. And this requires a understanding of VPN software itself. But here it is telling you that it is a client certificate. We are not using the bind name server. We are developing a TUN adapter for tunneling adapter basically. We are using remote certificate TLS server, which is the NAT machine, the OpenVPN machine that we have. Here is a private key that it has provided to us. In addition to the private key, it has also given us a certificate. This certificate is issued by vpn.cloudgenie.us. It is valid till 2026. And this is the certificate available to the client called Nilesh. And you can keep looking. You further have the certificate itself, which is the body of the certificate begins here and ends here. Then we have the certificate authority available to us, which is the CA, certificate authority. The certificate authority certificate is also included in that same file. We are making sure that we are using TLS authentication for connecting to that machine. And here is a OpenVPN static key, the 2048-bit long number that we generated, prime number, that is available here. And then we have a couple more things. We will use key direction 1, and the remote connection needs to go to this IP address at port number 1194 UDP. And we'll use that remote machine as our gateway as well. And so that is the entire configuration for OpenVPN. Now that is available to us locally. So me as an employee can actually use the certificate now I have called Nilesh certificate. And that will allow me to connect to this OpenVPN server. But that server needs to be started. It is not running yet. So we need to start that server, for which we have a step number 4. And so the step number 4 is we have to run this step, which will basically run that OpenVPN container in the remote machine out there. So we will go run step 4 and start. It will go connect and start a Docker container, which will run, do you see this long identifier, right? You see that? And that long identifier, do you see it? You should be able to see that long identifier another way as well. If you go to this IP address and SSH to it and say, show me Docker ES, you should see the same identifier right there, 1D71, 1D71F3, 1D71F3. It's the same Docker container that got created. It is running OpenVPN using this OpenVPN image, and it is mapped to port number 1194 for UDP. So you have this VPN connection already running. Now the VPN server is running there, but we are still not connected. These 4 steps that we did, I should make that clarification that let me exit out of the NAT box right now. So exit. In the NAT box, I'm exiting, and let us go quickly check our history, what we ran. And so the mistake I did in running the step number 2 was wrong. So I would like to clarify that was a mistake. Don't do it like that. I will clarify it like this, that I will create step number 1 should go like that. Step number 2 should go like this. Step number 3 should go like this, and then step number 4. These are the 4 steps that you should run. So I'm going to save it in the bin file itself, bin folder itself, and say readme. This is how you run it in that sequence by specifying a client name, Nilesh, for example. These 2 references that I missed. And that's what I was able to not successfully generate this configuration that is needed for OpenVPN to connect. Okay. Now, having produced a certificate for us to allow us to connect to that machine, our own VPN server, which seems to also be running as our NAT machine, what we need to do is somehow have a way to connect to the OpenVPN. How do we do that? We have created a certificate authority, generated a client certificate, downloaded a client certificate here, and then we started VPN server. 4 steps. First step, create a certificate authority. Second step, create a certificate for this employee. Third step, download it and give it to the employee. And fourth step, start the OpenVPN server. And so this employee now needs to use that certificate and connect to this server. How do you connect to an OpenVPN server? You need an OpenVPN client. This OpenVPN client, or just any VPN client, what these clients do is a very, very interesting thing. What they do is, you have a VPN server here. This is your private cloud. You have this VPN server running here. And you have this IP address range of 10.128.0/whatever that address range is. And in your location, you might have a different location in your company. You might have something like a local IP address, 192.168, or you might have 10.0.1.0, or any of those addresses. So these are private internet addresses that you might have. So what this employee needs to do is use a client, OpenVPN client. And I just want to make sure that you're still with me. I know we are running out of time, but I just want to make sure that I complete. We are way ahead of time, 25 minutes into it. So what I want to be able to quickly make sure that I clarify is that this OpenVPN client needs to connect to this OpenVPN server, thereby, and listen to this very carefully, thereby logically placing Nilesh inside VPC. Logically placing this employee that we have, he or she will be logically placed inside the workstation itself, will logically go here and be sitting inside the VPC, which means it will have an IP address in this range, in this CIDR. So you're logically moving Nilesh into the cloud. Not physically, just logically. And you see this logical moving inside the cloud. That's what is going to happen when you have this employee connect to this VPN server using a VPN client and the certificate, right? The certificate is required, without which no entry. So we need a VPN client. The best way to get a VPN client is to ask, how do I install a VPN client? So there should be a command, something similar to sudo apt-get install OpenVPN client. That should bring a new client application to our workstation right there. So let us see if there is such a thing. How to set up OpenVPN client. There should be the method defined in here. It is popping up right now. And it will tell us exactly what is needed to set up. Yeah, there it is. So here, that's the command, apt-get install OpenVPN, and then connect to it. So the commands are, oh, there's a Slack chat message, you are breaking up. So you should speak that, man. I rarely look at Slack chat. Yeah, if I'm still breaking up, please tell me if I'm still breaking up. Yeah, if you run into audio video issues, please speak out. If I don't respond, call me on the phone. So I'm running this installation on the workstation itself. I hope you're still there with me, right? Yeah, looks like you're there. So I'm going
right here, but you're breaking up.
Am I still breaking up?
You're breaking up. Yes.
Wow.
Yes, you are.
Okay, hold on. Let me check. Let me check a couple of things. Okay, is it still okay or not okay? Do you still hear me okay or still breaking up?
We can hear you okay. I think it has something to do with the bandwidth, so it's fine.
I guess so. Maybe a transient problem because I cannot figure out any bandwidth issues on my side. So I have installed OpenVPN client on this machine by doing those things. Like you saw me do this, I'm going to make a note of it for you as well. So what I did was I installed the OpenVPN client on the machine. This is the employee running. And now I will run OpenVPN client and provide a path to the OpenVPN client. Like this is what I need to do. And so my configuration path I need to provide, which is in my example, it will be something like nilesh.automated something.openvpn. That's the name configuration I think I have. Let me go cross check. And so the name is nilesh.automated VPN. This is my configuration stored. I need to use that configuration and run this command like this. And so I will take that command back here. And then first of all, check some IP configuration. So you see that I have a Docker IP address, an Ethernet 0, and a local network, 3 network adapters in my workstation right now. I will now run this OpenVPN client configuration and pass it a reference to the OpenVPN configuration that I downloaded from my OpenVPN server, right? So I'm going to hit it and it will establish a connection to my cloud, in the cloud. So now I have it, I have connected. And we can open a new terminal right now. And in that terminal, we'll examine what is our IP configuration. And we will also see if we can ping. Let us see if we actually succeeded in connection or not. Yeah, it is still establishing connection. So it is peer connection initiated, and now connection sequence completed. And now we have a new adapter popping up. You see a new adapter popped up here, tunnel adapter. And this is a adapter connected, available to us on our computer because of OpenVPN. You probably remember that I saw Docker, ETH0, and local, but now we have a new adapter available to us. And it is logically placing us inside that OpenVPN machine out there. And with that understood, we should be able to ping our where is that IP address? I'm trying to grab our IP address for the machine out here. We should be able to ping the internal private IP of the NAT box. Let's see, can we ping the internal private IP like that? And yes, the response time is a little long, but it is pinging, right? You cannot ping a NAT machine in Amazon, but we are inside, logically inside the VPC. So it is pinging successfully. Why is it pinging? We are connected through VPN. That is why it is able to ping. If you break the VPN connection, it will not succeed in pinging. Now, I just pinged the internal IP address of the NAT machine. I want to now go to the app0 machine, which does not have a public IP address at all. What I will do is grab the private IP address of the app0 machine and bring it here. In this window on the left side, we have the VPN client connected to the VPN server. So I'm just making it making it the lower left corner, keeping it aside, and focusing primarily on our other terminal, which is what I want to get to, which is this terminal. So in this terminal, I want to be able to ping the app0 machine. And by the way, this time, as you notice, we are not using a SSH tunnel, but we are using a VPN connection. And it is comfortably pinging machines inside the private area. Not only that, you can connect to those machines as well. And since we are inside the VPC, it should allow us to connect to the app0 machine just fine. And we got connected, by the way. And so it is slow because the machines are small, like T2 Micro, but it is working. As you can see that this machine app0, we are able to connect in the VPC inside in a private area. And in that machine, as you know, we are also running Docker. So sudo Docker images. We have an image called Nginx running there, as you know. Similarly, we will say that we have sudo, okay, come on, sudo, please. It is slow, So bear with me, please. Okay, the machines are far, far away from us. So it doesn't interactively respond. And the machines are cheapo T2 Micros. So sudo, I thought I typed, but then too much latency. So breaking it one more time. Okay, please respond to me. There, good. Sudo, I'll type slowly and be patient. And so sudo and then docker ps-a, show me the running container, and you should have a container running Nginx. There we go. So now, can we see the output of the container? Curl, localhost. Can you show me what you have? And it says, I have HTML, doc type, this and that, Nginx showing up right now. Bingo. Awesome. So what I want to now do, we are on app0, right? So what I want to be able to do is go inside this app0 Nginx Docker container, which is 656F, by the way. And in that container, I will like to modify this HTML page a little bit to illustrate the point of load balancing. This is very critical to understand, that you have to really distinguish that we are dealing with two different boxes. Right now, this runs Nginx, this runs Nginx, and you cannot tell which one is which. So if you visit this load balancer here, you should actually see Nginx comfortably, which you should see right now. We should go to the load balancer, where you will find that you have these two boxes now in service, which means we can go to the automated VPC description, get the DNS name for it, and then open in a new browser and see Nginx right there. But the problem with this Nginx, if you keep hitting, and by the way, all of us can hit the same location. If you keep hitting, you don't know whether it is app0 responding to you or app1 responding to you. You have no idea. Literally no idea, because you cannot tell, because it is all Nginx on both machines. So I would like to make a change in the code itself to tell us, you and I, that you are now dealing with app0 versus app8, just to illustrate the point. So I'm going to go inside this Docker container, inside app0, and label it differently. I will do that right now. So it means I need to run Docker, run interactively, and engage with that particular container, and then run bash inside. Okay, I made a mistake. So sudo docker run, it's not now docker run, but docker exec. Docker exec, and now I'm inside the container. I should modify a file called vi and vi var. Where is the file stored? There has to be a location where this file is stored. So I'm trying to locate that file. And where is that file? So that location I can easily detect by going to this location. Okay, I think it is var log nginx. So the location is cd/var log. No, it cannot be log. Where is that location? Hold on. Let me find its location. So nginx default HTML location. And that location is, oh, user share nginx www. Fine. So we found it. The location is user share nginx www. That's the location where it stores. And in that location, we will have a file called HTML. And in that file, it's a folder called HTML. And in that file, I will modify the index.html file to say that you are, oh, we don't have VI here. Okay. And so, so we are dealing with the multiple operating systems. I don't know which operating system is this, but I don't think it will allow us to modify. Which operating system is this? It's inside Docker container. So we should have, this should be Ubuntu, right? Cat etc/release. It should be Ubuntu. No, it is Debbie and Jesse. Okay, so do we have Nano? No. What about Vim? No. So I think update, apt-get update is needed for Vim to get available. So apt-get install -y, not py. And now it should install Vim, and I should be able to edit that VI index.html file. Now we are getting there. Okay. So the title and the body h1, welcome to, and I will replace this to say, welcome to app number 0. And save. And the other one, I did not change anything, which is, you understand that I did not. Which means now we can go here and refresh and see what happens. You see what is going on, do you? I'm constantly refreshing the same load balancer page. And what is going on? Do you know? Can you tell? Anybody? Are you still there?
Yes.
Okay.
Load balancer different server.
We're still here.
Yeah, so what is going on? What did I just do? Sometimes it shows me nginx. Sometimes it shows me app0. What is going on?
Load balancer different server.
Bingo. Yeah. So exactly. So what is going on is that I modified the HTML file inside this Docker container that runs nginx container. So I went in there and hacked and made app0. And this one is running Docker container, it runs nginx container, it runs the default. I made that little change to illustrate to you. And how did I even go in there? I did a lot of things, like, crazy things. But once you do it one time, it is really simple. What I did was used my VPN connection, and here I am in my office. And in my office, I have this workstation that I'm using. In that workstation, I'm connecting like this. Oh, no, sorry. I'm connecting like this. And then I'm hacking it. Whereas this user is able to now see app0, app1, app0, app1 all the time. It's toggling. This toggling is happening because because of your load balancer. There are two instances, both in service. As you can see, both of them in service. So it is basically diverting the load 50% here, 50% there, round robin, A, B, 0, 1, 0, 1. If you have more containers, it will include them, no problem. And that's the scenario that you just saw, example, in which we did include a new idea, which is basically OpenVPN into our game. The OpenVPN connection is still established. It is running in this window. And you can run it as a background process if you like. But it basically logically placed my laptop in the Amazon cloud. I'm logically there, even though physically still here. I'm logically included in that configuration, which means I can ping any of these machines naturally, like as if I'm there inside. And I don't have to worry about SSH tunneling and all that complex stuff, which we did, I think, a long while ago. And so we are able to use VPN methods, which are more easy for everybody. Just give every employee, where is that thing here? So give every employee one certificate, and they are able to logically connect using that certificate that you will provide, and then use their VPN client and just connect to the VPN. And then you logically place everybody inside the VPN, inside the VPC, so that they can access whatever resource that they have inside the VPC. That's the easy part. But from the user's perspective, if you notice that, say, one of these machines by chance like dies, I'm going to kill one of them, for example, terminate. Here we go. So, or rather not kill like this, but instead just, stop the Docker container in there. So I'll say, give me the IP address of your app number 1, and here are your 212. This is the application internal IP address app 1. So I'll say SSH Ubuntu at IP address internal to the other machine app 1, and I'll say you should stop your Docker container. So I'll say, where is Docker? Oh, sudo. And so that container I have, I should kill it. Sudo docker rm-f a51, and it dies. So the Docker container is dead, which means I don't have any Docker containers running, which means my load balancer should start showing problems. Health check failed. I should see health check failing any moment soon. In the interval timeout, 15 seconds, I should see that health check is failing because our machine is showing app 0 all the time. There is no other machine available. It's all the time. I'm refreshing it constantly, and it is continues to show me app 0 because the other machine has been marked dead. And with this understanding, I'm going to come out of this machine, exit, back in my Terraform, and all I can do here to clean up is say Terraform destroy, and say, are you sure? And I'll say yes, and it kills the whole thing. And now we will see the VPN connection breaks and all that. So all these things will happen momentarily, but you get the point. You get the point. The point being that it worked. It worked. Yes. Yeah, it worked. Whereas the other thing that I wanted to show you never worked, which was CloudFormation. Where is that thing? It didn't even bother to respond to us. I mean, come on. Yeah, it died because we killed it. But it was not responding. I tried 3 or 4 times. In our Virginia cloud, the whole thing is dying right now because we killed it. This death is happening. And that is what we wanted to discuss today. So I think this VPN part is a little bit complex to digest. So I'll do it again. Don't worry. I know some of you are new to VPN, and I think it is an ingredient, an essential ingredient in any kind of architecture you want to lay out, where you need to have a VPN established. So it is very easy once you have a framework of reference to deal with. I will do this VPN exercise one more next time, which is tomorrow, by the way. Yes, it is tomorrow that we are meeting again. And so right now it is 49 minutes over. Ouch. Sorry about that. I just run long. I should not do that long. But sometimes it is interesting and sometimes it is just long. I mean, sorry about that. But I should maybe break it. If you think that I should break it, I will. Or I'll basically go on what you tell me. But having understood this, are there any questions on this? I would like you to repeat this, try it out, play with it, modify it. Not just try it as is, but actually make changes to it. Make changes to apply to your scenarios, include your examples, modify it, and more importantly, put this to use in real life. And it applies to any cloud, not just Amazon. So you can do the similar thing as long as the underlying cloud provider supports it. It will work. You have to go check Terraform documentation and write similar constructs for other cloud providers. They're all the same, conceptually the same. You just have to identify the right set of syntax to use, which is available here in this example. And then there is documentation always, all the time. And that's what we just did right now in this particular exercise. Any questions? Anybody? Nobody? You're tired. I know. I know you can get tired listening to me like this. It can get challenging and exhausting. But we successfully killed everything. And before I forget, I should kill one more thing, which I always forget all the time, and I need to remember, is to go to the Identity and Access Management toolkit, identify that user called Terraform, and kill it. So go user, bye-bye. I don't want your key alive. So the key is dead. Nice. So this YouTube, the video will go on YouTube, by the way, this video for today. And nobody can actually make use of that key because the key itself is dead. Questions? Any questions or no questions? I have a question for you, by the way, if you're still there. So if you do not have questions, let me ask you a question. Are you ready?
Yes.
Okay. Okay. I have a simple. It's not a question. It's a request. The request is to all of you, and the request is I would like you to provide me with a feedback for other students in the future as to what do you think, how did we do this? We have 2 more sessions going, right? So this is the feedback that I accumulate from people who attend the program. And what I do is ask them to write about, how do you find it? How was it? And this thing helps other people in the future in understanding and learning about perspectives of, what you think this program is actually doing. So we have collected these over time. And what I would like to request you is to give me what you think is this course. How do you find it? What do you find useful? And what do you want to do with it? Like, how will you apply it? That's what I would like to learn from you. And so the question I have essentially is, how did we do? How do you find it? Good, bad, and how will you, oh, rather, one more. What are your 3 takeaways from this bootcamp? And how will you apply these in real life? That's what I would like to hear from you. And so you can give that to me in email or Slack chat or whatever you feel like. Email is best. My email address is here. And so please write that. Like, it does not need to be long. You know, as I gave you some examples, it does not need to be long. It can be like really short, 2 lines, 3 lines. That's it. That's it. That's what I would like to ask you, is to write and attempt to answer these questions. How did we do this boot camp? Do you find it good, bad? What are the takeaways? What did you take away from this boot camp, and how will you apply in your real life? That's what I want to hear. And that is what I ask. I hope you will give me something. Thank you. I really want to find out, how do you apply what we take away from here? That is what I really am interested in, is the application part. You know, what will you take from here and do with it as you complete this bootcamp, which you should on 29th. So the takeaways is what I'm really interested in finding out from you, and how will you make use of that in real life? So please write that. Hope you will. Thank you. Hey, Munir, are you still there? Munir.
Hey, Nilesh.
Hey, can you call me, or maybe just stay online after other people go? I will talk to you briefly.
Yeah, absolutely.
Yeah. So I think if there are no more questions, you are free to go. But please give me an email which tells me how to apply these things in real life. That's what I'm really interested in hearing from you, and I hope you will do that. So please write that in email. And if you want me to write you this in email, I can do that, but I don't think that is needed. So thank you, Salam. And so you are welcome to hang off, drop off, and we will meet again tomorrow, 5 o'clock Pacific, 8 o'clock Eastern, and see you that time. We will do more of this exercise to help you, take that to real life in real scenarios. We'll play with this until you really understand there are too many levels of depth needed to get to the level of depth that is needed to understand and fully comprehend all the way end to end at the application level through the load balancer. And we'll expand this discussion today into other areas, such as providing a high level of reliability, availability, and disaster recovery, and those things, which you can play in real life. So you will see that next time we will run it. And let's do that tomorrow. And then last session on Friday. Thank you.
Thank you.
So how you been, Nilesh? How was yesterday?
Hey.
Yeah. Yes.
Yeah. Hold on a second. Hey, Nilesh. I apologize. Tomorrow, I'm gonna have to leave the class early. I'm sorry.
Okay. Yeah. You can drop off, no problem. And if you want, I can. Yeah. No worries. No worries.
Okay. All right. Thank you.
So, Munir, it's you and me. So, how are you finding it?
I got a little lost and I'm trying to catch up, but I don't want to hold everybody back.
No.
So I've been trying to watch the videos and trying to.
I know. I think let me stop.
The recordings that I had downloaded from previous classes.
Yeah.
And I tried meeting with Salam, but it couldn't get it to work out. And I tried to download on this laptop. Obviously, on this laptop, I can't get their cloud